See, you are the yes.
Sir, is my screen are visible?
Yes, yes.
Okay, so we start with this. Good
Yep.
morning, everyone. My name is Supriya Singh, and I am from Jawaharlal Nehru University, New Delhi. The topic of my conference is QoS Aware Service Placement for Fog Integrated Cloud using Modified Neuro Fuzzy Approach. And the outline of my presentation is we start with the introduction, then we move on the problem statement, contribution of work, a bit discussion on the proposed methodology, result discussion, and end up with the conclusion and references. So here we start with the introduction. The term IoT was coined by the Kevin Ashton in 1999 and refer as the network of physical things or objects that have sensors and network connectivity to perceive the data from the surrounding. As we seen in this figure, nowadays any of the device can treat as a IoT device until or unless it has some sensing and network connectivity. And these days billions of IoT devices are interconnected to each other, and they are produce enormous quantity of data for various innovative applications. And to process such data, some computing platform is required. From the few days, this cloud and fog now incorporate with IoT to process and infer the knowledge from substantial volume of data. Cloud node refers to the data center that comprise of highly strong machines, like server, etc. The problem with cloud computing is that they are situated very far from the end user, which contribute to latency encountered while accessing the cloud-based service. And these delays sometimes become a bottleneck for the service that require ultra low latency, like health-based services. So to address these issues, Cisco proposed another computing layer that is in between the cloud and the IoT layer, is called fog layer, and it is in the close vicinity of the user. Even we can see in this figure, the first layer refers to the server layer, that is cloud layer. The third one is the IoT devices that generate the data, and to process this data, there are two layer: fog layer, which comprises of networking devices, and the topmost layer, cloud layer, which comprises of servers. So by locating the resources at the network edge, the time required to traverse a data up to processing layer is reduced to little amount of time. Generally, generally the routing device can be treated as a fog node. Their primary work is to route the data. At the same time, they have some small amount of storing and capacity power. That's why they are treated as a processing node in the fog layer. The computational resource in the fog node cannot be large enough as in cloud. So the motive is the lightweight service, or the service that require quick response, will move to the fog node, and the service that is delay tolerant or large scale job will push toward the cloud nodes. In our proposed work, we are going to utilize the hybrid architecture, a cloud fog architecture, to produce the desired result in terms of resource provisioning and management. And the motivation of using this hybrid architecture is to disperse the workload among the different layers, so that the problem of overutilization, underutilization is addressed. The problem statement of this research is the service placement problem. The problem is how we can decide which of the service is placed on the fog node and which one is migrated on the cloud node, that necessitate the requirement of intelligent decision support system. Even in the dynamic world, the service requirement cannot be predicted. To cope up with this uncertainty, few of the researchers utilize fuzzy logic. But fuzzy logic is a rule based model in which the rules are made by the expertise of this domain. It is a static method in which don't have a capacity to learn by itself, to predict by itself. It just work on the basis of rules, and also have a difficulty in appropriate membership function. So nowadays, people utilize the self learning capacity of ANN, means artificial neural network with fuzzy logic, to develop a new integrated model called ANFIS, adaptive neuro fuzzy inference system. And we are here to utilize this model to make a smart admission control manager that predicts a suitable tire for the service coming from the IoT devices. The contribution of this work is actually a modified version of the existing research that is stated in the reference part 6. This work is going to utilize machine learning based methodology for the clustering and the prediction of computing layer in fog integrated cloud. The existing research mean that in reference 6 utilize the NFIS model for the prediction of computing layer, but we analyze that the NFIS is a deterministic algorithm that utilize gradient descent for the training of model. Basically, NFIS is a machine learning model that comprises training and the testing of model. And for the training, it utilizes gradient descent method, but the gradient descent have slow convergence rate and also have big chance of trapping in local minima. So in this paper, we are going to utilize meta-heuristic based algorithm instead of deterministic algorithm for the training phase of NFIS, and the effectiveness of model has been evaluated by comparing it with the base NFIS, where we use conventional gradient descent method for the training of NFIS model. The proposed methodology of this work is, uh, starting with the description of data. We are going to use real-time data, Google cluster trace, to portray a high level of realism for the proposed study. This has been extracted through GSUTIL package using database query. This comprises of various relation, but we are consider only two relation: task event and the machine event. And the whole data is a natural join of task event and machine event, and the service that coming from the IoT is characterized by the various attribute in the Google trace, but we are consider only five attributes: the CPU, the memory, the disk required by the service, delay sensitivity of the service means how much service want to respond quickly, and P stand for the priority of job. Because we are going to use machine learning based service, so we need a training data. Initially we have a raw service set with no label. To attach a label, we are using a fuzzy c-mean clustering on the parameters c, m and d to find the belonging degree of each service with respect to each cluster. And after that, we are manually added the delay sensitivity and the priority of the job to update the cluster data. As we seen in this figure, the blue color cluster refers to the service cluster of those service requests which require a very less amount of storage and the CPU, while the green color cluster refers to the service that requires significant byte of memory and the CPU core. And this is the architecture of NFIS. It is a layered architecture which comprise fuzzification rule, normalization, defuzzification, and summation layer. As I said, the service is characterized by using five input, and because we are going to use fuzzy logic basics, so the three linguistic values are high, low, medium. And obviously, output with a single value. It might be either the fog node or the edge node or the cloud node for the service request. The brief discussion of the functioning of layer is like that. The first layer contain a membership function that determine the degree to which the given input satisfies the linguistic variable according to chosen membership function. In equation 2, as we seen that the shape of the membership function is determined by the parameter a, b, and c, and these are the premise parameter. Initially, these premise parameter are chosen randomly, and each every iteration they are updated to get a suitable value for ABC. And the second layer is rule layer, in which we are trying to compute the strength of each rule by multiplying the membership value computing in the previous layer. The third one is a normalized layer, and the fourth one is a defuzzification layer. This is the layer actually where we try to feed self-learning capacity in NFIS. If we see the equation 6, this is PIA plus QIB. This is exactly like a linear regression equation where PQR are the consequent parameter, and these parameter are update iteratively. It means that the equation 1, where we discuss about the premise parameter, they are playing a major role to define the membership function. On the basis of membership function, rules are made, and the PQR, the consequent parameter, they also update iteratively to get the suitable value of FI. So The whole working of NFIS is like that. In the first phase, we start with the random chosen premise parameter, calculate the node output, and using the gradient descent method to update the consequent parameter before calculating the final output. And after that, because it also follow neuro approach, so the error is propagated backward until the first layer, where NFIS again update the parameter of premise parameter and the consequent parameter to tune the output. The appropriate choice of the number and the shape of membership function determine the cost of training and the computational complexity of the network. The training of NFIS refers to the updation of premise and the consequent parameter to get the optimal value. And as I said, among the all layer, the first and the fourth layer are adaptive, while rest are fixed. In the existing research, mean the research defined in the number 6 use gradient descent as an optimization algorithm for the training of model. Even the few researchers utilize hybrid approach like gradient descent for optimizing premise parameter and least square error for optimizing consequent parameter. But the gradient descent is a deterministic algorithm. It has a value called alpha, that is learning rate. It means that it always move uniformly toward the optimal solution. Hence it is slow and sometimes trap in local minima. So in this paper we incorporate natural inspired meta heuristic approach for the modification of these parameter. Meta heuristic are stochastic and greedy in nature, in which random step are taken toward the optimal solution, and convergence rate is bit high than the deterministic approach. This is a flow chart of my proposed model. We start with the making of testing and training data. Then by using the function of the layers, we are implementing the fuzzy inference system on the basis of number of input, the linguistic value of the each input. Then we are to and in the second pass, we are trying to optimize the consequent and the parameter problem that come in the NFIS training part, where we use gradient descent, meta heuristic based genetic algorithm, PSU, and the J algorithm. Then we test the model on the basis of R score, testing error, and the error deviation as the performance measure. Then we come to the result and discussion part. These experiments are implemented on the MATLAB tool. We have constructed 3 batches of various size to test and train the model. Batch 1 comprise 800 surveys, batch 2 comprise 1600, while batch 3 comprise 2560 surveys. We take the batch of different size to generalize to see whether the model is affected by the size of training set or not. We consider R score, testing error, and error variability as a performance measure. And the performance of all the 4 model means NFIS, GA NFIS, PSO NFIS, and JA NFIS has evaluated on the 3 different batch under 2 conditions: noise or without noise. Noise is introduced to check the robustness of model to avoid generalization error and fault tolerance. So these are the some reading of batch 1, batch 2, batch 3 on 0% noise, 5% noise, 10 and 20% noise. And from these reading we conclude that uh, the meta-heuristic based NFIS outperform the standard NFIS that use gradient descent. And at the 0% noise, the R score is almost similar, but as the noises increase, the value became degraded. And the batch 3, um, batch 3 made make more accurate more produce more accurate result. It means that as the number of training set increases, the performance of model is enhances. And this is the some graph between the epoch and the R score and the epoch and the testing error. And it can be
Please
evident,
conclude.
it can be evidently seen that the Jaya and FIS perform the best result, and obviously meta-heuristic based algorithm outperform the standard and FIS. So the conclusion is that we are trying to make some intelligent decision making technique to find the computing layer for the service request, and the simulation shows that the meta-heuristic based neurofuzzy model meta-heuristic based neurofuzzy yield imperative result against the gradient based neurofuzzy, and the degree of efficiency has been determined by the introducing various level of noise into different batches. Thank you.
Yeah, fine, Supriya. So, you have solved the problem regarding overutilization and underutilization.
No, sir, it's not like a over.
Yeah.
We're just trying to make us smart admission control manager that decide
Hmm.
which of the computing layer is suitable for that particular service.
Okay. And the reference number 6, what you have mentioned, what is the modification you have done? And that reference number 6 is your work or it is some other researcher?
No, sir, this is some other works. This is the
So what is the
optimization.
modification you have done in that?
Modification is that we are using a different approach for the training of model. They are used
Okay.
deterministic based approach, and I'm going to use meta heuristic based approach.
Okay. Why you have gone for meta heuristic? Can you justify?
Yes, because I said Gideon descent is a deterministic approach where there is a one factor called alpha convergence rate. It always go uniformly toward the solution. So the convergence rate is low. But in meta heuristic, we always take a random step to reaching toward the optimal solution. And even in the research that conclude that GD has a high probability to trapped in local minima.
Okay. You have not compared your results with the existing work.
सर किया है एनफिस से किया है Can I show?
Sorry?
Sir, I did it. I just compared with the base NFIS model.
Okay. Can you show?
This yes, sir. This R line, this
Okay.
R there.
Fine. So how you are validating that? And why you have taken five-fold approach for validation?
So actually, I have taken start with 5 to 10, and I got best result on five cross validation. That's why I just choose it. मतलब it just taken experimentally.
Okay. No, no any scientific reason why five-fold? Nothing.
No, sir.
Okay, fine. Thank you.
Thank you, sir.
Next paper.
Just a
Paper
minute.
ID.
Anusika Gosin, are you there? Harsh Sharma, paper ID 200 Authors, are you there? Okay, so I need to play his pre-recorded video, sir.
Okay.
Just let me.
Hi, I am Anish Gurusamy, and I am presenting the paper titled Oversampling Methods to Handle the Class Imbalance Problem in a Review.
Sir, is audio
Yes, sir. It's good. It's good. Yeah.
The paper ID is 20. Review work of oversampling methods used to handle the class imbalance problem occurs when the class distributions are highly imbalanced. The total number of a class of data is far less than the total number of another class of data. Hence, the minority group contains significantly fewer samples than the majority group. The approaches to handle the class imbalance problem can be grouped into three categories: external approaches, internal approaches, and hybrid approaches. For external approach, the dataset is resampled either by oversampling the minority class or undersampling the majority. In internal approach, new classification algorithms are developed or the existing ones are improved. Hybrid approach, as the name suggests, combines the data level and the algorithm level approach to take advantage of both the categories. The oversampling methods used are mode, safe levels mode, mode atomic lengths, Bottom-end mode, and adaptive synthetic sampling approach. We have considered 10 different data sets that evaluate methods. All these data sets have been taken from table repositories. We have considered 5 properties of these data sets. dimensions, dataset size, minority class, quality class, and imbalance ratio. The dimensions vary from 7 to 25. Dataset size varies from 155 to 5,472. Minority class varies from 14 to 559. Majority class varies from 123 to 4,913. And the imbalance ratio varies from 0.02 to 0.52. In this paper, we have empirically evaluated 5 oversampling methods before to handle the class imbalance problem. We have considered 5 performance metrics: accuracy, precision, recall, F1 score, and area under the curve. The results have been shown for 4 classification models: precision trees, support vector machine, random forest, and k-nearest neighbor. Here we can see the results for decision tree classifier. This slide shows the results for support vector machine classifier. The results for random forest classifier. And here we can see the results for k-nearest neighbor classifier. To conclude, we can see the smooth formulations outperform the other oversampling methods in performance metrics for most of the datasets. This is because it first performs a noise cleaning method and then generates a synthetic responses. For future work, we will validate the results on high-dimensional datasets. The references used can be seen on this slide. Thank you and have a nice day.
Author of paper ID 200, are you there? Okay, because of time difference, we have this pre-recorded video, sir.
Yes.
So if any participant or if you have any kind of query or question, then you can type it in a chat box. We'll forward to her. Sir, shall we move to the next paper?
Yes, sir. Sure, please.
So next paper is 221. Author of paper ID 221, are you there? Sandeep Das. 221 authors, are you there? We have pre-recorded video.
Okay, sir. Yeah.
Today, we will be discussing about the topic explainable AI for predictive analysis of employee attrition. Here is the Dr. Smith and Michael Predictive Surgeon who will be presenting this research work today. So, employees are the key to an organization's success. An employee can directly affect the productivity of an organization. Hence, retention of employees becomes a great challenge for every artificial intelligence is extensively used in such cases to analyze problems behind the company's low retention rate or valuation. The analysis can help organizations to build up strategies to deal with the problems of employees within an organization. The current work aims to detect key features or main reasons behind an employee's key decision to A or leave the organization. Primarily in this work, machine learning is used extensively to create a prediction model of the collected data from human influences of different companies. This presentation includes these topics: the objective, methodology, implementation, conclusion, and limitations and future direction. Our objective is to explain the factors of employee attrition and help organizations strategize retention strategy. Moving on to methodologies, we have used random forests as our algorithm, which is a tree-based inferential learning algorithm. And later we use explanatory AI to explain how our model works. So explanatory AI provides a better explanation for black box machine learning algorithm. It provides better insights to the prediction and makes machine learning prediction more interpretable and transparent. So let's start with the implementation. Our dataset was a human resources data that contains 9 parameters of 15,000 employees. For data for pre-processing, our dataset had 2 categorical and 8 numerical features. We applied level encoding to the categorical features for the sake of not losing the feature. For the classification task, we used 5 different classification algorithms, which are random forest, XGBoost, KNN, limit and support vector classifier. So comparatively, random forests give a better score in terms of accuracy, which is 98.18%. So we chose random forest for that reason for our model. We did plot an ROC curve, which gave us an AUC value of around 98%, which is pretty good AUC value. So moving on to the Excel implementation. One feature important. You can see that globally satisfaction level provides the most towards employee leaving or staying in the organization. And in a descending order, time spent in company, number of projects, last evaluation, and average monthly hours also provide to the prediction. But we can also see that salary and department almost doesn't, and work accident or promotion in last 5 years doesn't provide in the prediction. So we'll be moving on to other graphical representations of share. For the summary plot, we can see that these features are ranked in descending order, whereas satisfaction level has the highest importance and later on time spent company and others. So this is a summary plot which says that if the satisfaction level is low, then the employee has a high chance to leave the company. And for the time spending company, more time, if an employee has spent more time in a company, so he has a higher probability of leaving the company, and so on and so on. For the dependence plot, we can see that the dependence between time spent in the company and the salary. The dependence plot shows the dependence between two features. So we can see for this point that if an employee has spent over 10 years in the company and has a low salary, then he has a high probability of leaving the company. Two instances from our original dataset for the first of share. For the, we can see that the base prediction value of our model is 0.2327, and the features which are coded in red color, which is the value higher, and features coded in blue color, which is the value lower. And for the 2012 question, the final value becomes 0.20, where department promotion in last 5 years has provided to push the value higher, and features like number of project satisfaction level, they have provided it pushing the value low. So the ultimate value becomes 0.20. And similarly for 11,069 question, the final value becomes 0.3. Why? We have chosen the same two instances. The 2012 instance was predicted as 1, which means the employee will leave the company. The instance contains these set of values for each feature. So we can see that some features are coded in orange color and some in blue color. The features coded in orange color provide to the positive side, which means that they will leave the company, and features coded in blue color provides to the negative side, that the employee won't leave the company. So for example, we can see that number of projects is blue, and it has provided towards the negative side, that the employee will not leave the company. It has provided the amount of 0.03. Why? Because it holds a value less than equal to 3, and so on and so forth for other features. And we can see for the 1169 instance, the predicted value was 0, which indicates the employee won't leave the company. So here we can also see that, like the last evaluation, which is coded in orange, which holds a value of 0.33. It has provided 0.02 towards the positive side. And why? Because it has a value of less than 0.56. Our current work has analyzed the possible factors behind employees leaving the company. From the given dataset, it was found that satisfaction level is the top priority of employees. Additionally, the employees' tenure at the current organization and workload is also other major factors behind employees' decision to stay or leave the organization. This work was focused on results obtained from the random forest classifier model, and in the comparative study made, it was the one that led to the highest accuracy score among the tested frameworks. Based on the obtained results, the study was focused on in-depth analysis of features using shape and line in order to explain the features and their importance level in detail. Here are some limitations and future directions for our project. Like only the gathered data was analyzed, which may not have included other factors that could result in different analysis and outcomes. Like for other organizations, the reasons may be different for employee attrition. In future work, we may consider other factors and use different explainable AI frameworks other than line and chat to make further analysis. Additionally, the other techniques such as deep learning or reinforcement learning may be used to create the prediction model. Here are the reference of our work. Thank you for listening to today.
Author of paper 221, are you there? Okay, sir. Shall we move to the next paper, sir? Dr. Patil? Shall we move
Am I audible?
to
Yeah. Yes, sir.
Yes.
Yes, sir. Yes, sir.
So next paper is 228. Author of paper ID 228, are you there? Kamaldeep Kaur, Dharminder Singh. A pre-recorded video.
Okay, fine.
Myself, Kamaldeep Kaur, research scholar, IKG Punjab Technical University, Kapurthala, and assistant professor running the engineering college, Ludhiana. Thank you very much for the acceptance of my paper. So, starting with the presentation on my paper that is titled Extraction and Analysis of Speech Emotion Features using Hybrid Punjabi Audio Dataset with the paper ID 228. Starting with the introduction, we as humans communicate with each other by exchanging information through many ways, which include speech, body language, facial expressions, etc. And among all these ways, speech is the primary form of communication. Listing information such as language, and the other one is the implicit or the non-linguistic information that has to be extracted from the speech by using various speech processing methods. So the speech recognition allows human beings to use their voices to speak with a computer interface in a way that resembles normal human conversation. Speech carries a lot of information about the speaker, language, emotions, which can be extracted in the form of identification of speaker, language, gender, age, and emotion recognition. The emotions are expressed best in the form of speech while humans communicate as compared to the other forms of communication. An emotion can be defined as a psychological state of mind, which is a combination of subjective experience, physical response, and behavioral response. Coming towards speech emotion recognition, it is defined as extracting the emotions from the speaker's speech. It is very easy for a human to identify the emotions in a speech, but it is very difficult for a machine to do the same. The speech emotion recognition finds applications in many fields, including security, e-learning, medicine, monitoring, marketing, call center, etc. in real life. Now, this is the broad architecture of speech emotion recognition system, which starts with the data set. The data set is divided into training samples and the testing samples which are given to the feature extraction module that extracts the features from the speech. Then the redundant features are removed by the feature selection algorithm, and appropriate features from that module are passed to the classifier that then classifies or recognizes the emotions. Now, an extensive research work has been found for on the speech emotion recognition in terms of different foreign and Indian languages, databases for various languages, various feature extraction techniques that have been used by the researchers, the various selection methods and classification techniques. We have found a lot of work on foreign languages such as English, German, Mandarin, Chinese, Danish, Spanish, Persian, etc. Apart from these foreign languages, work has also been found for Indian languages such as Hindi, Marathi, Telugu, Malayalam, Bengali, Oriya, Tamil, Assamese, etc. But after the extensive review of the literature, it was found that there were some gaps in the research, such as the non-availability of standard speech databases for Indian languages and the language such as Punjabi, which has not been touched in this field due to its geographical confinement of the speakers. So recognizing emotions from speech was a challenging task for regional language like Punjabi. So the main focus of the study was to develop a speech emotion recognition system for Punjabi language. For that purpose, a methodology was adopted which consisted of these 5 steps. First was the creation of data set, then pre-processing, then extraction of features, followed by selection of features, and then recognition of emotions. Step was to create a data set in Punjabi. A hybrid data set was decided to be created for Punjabi due to the fact that there is not a success for a particular type of database. So a database was created with the mixing of recordings from professional speakers as well as recordings from the online resources for all the purpose of speech emotion recognition from Punjabi language. 6 basic emotions such as anger, happy, fear, neutral, sad, and surprise were chosen. And 900 speech files were constructed, which constituted 300 from professional speakers, 300 from non-professional speakers, and remaining 300 were collected from the online resources such as plays, TV shows, radio, movies, vlogs, news, stories, interviews, political speeches, etc. This is the list of the 10 Punjabi sentences. Those were neutral in nature, which were given to the professional as well as non-professional speakers to utter these sentences in different emotions so that a data set could be constructed. After the construction of the data set was tested by few listeners so that if there is any problem in the data set that could be then re-recording would be done. And this testing was evaluated in terms of recognition rate for different emotions as well as confusion matrix for different emotions. Now, these are the specifications of the dataset in terms of speakers, age group, emotions, sentences, environment, hardware, software, sampling rate, channel, bitrate, audio format, etc. After the creation of Punjabi audio emotional dataset, pre-processing was followed in order to remove the undesirable noises that could have occurred while the recording was done. And for this 3-step pre-processing was followed, which included noise reduction with the help of Kalman filter, and cancellation with the help of an LMS with FIR filter, followed by signal smoothing with the help of linear filter. After pre-processing of the speech signal, features were extracted. It was found from the literature that rather than using a single feature, fusion of different features resulted in better accuracy. So it was decided to extract a number of features, which is shown over here in the form of spectral as well as prosodic features. A total number of features which were extracted were 16 along with their attributes, which counted up to 418 features such as 120 MFCC mean features, 12 chroma mean features, 128 MEL mean features, and so on. That totaled up to 418 with these 16 features. After these extraction of features, it was necessary to optimize the feature set because there could be some irrelevant or some recurring features. So less so that was least absolute shrinkage and selection operator algorithm was used, which selected 288 features out of 418 features and worked at its best by removing the least important and repetitive features. After the selection of features, emotion classification was done using 1D CNN. These are the hyperparameters and network tuning that was done in terms of number of convolution layers, filter size, activation function, mask pooling layer, dense layer optimizer, etc. Now the experiment was performed on this created data set for Punjabi, then 418 features with the feature selection algorithm lesser than with one the signal classifier for the whole process. Out of 900 total utterances, 720 signals were used in the training part and remaining 180 were used for testing phase. And this experiment was analyzed in terms of precision, recall, F1 score, and accuracy. This table shows these values for different emotions. As we can see, the average values are approximately 73%, which was a good score as compared to the other SER systems for different languages. The results are also shown in the form of graphs, such as precision result for each emotion, recall result for each emotion, F1 score, accuracy, and then confusion matrix. So coming, we can come this SER system for Punjabi is also performance of various other standard speech corpus SCR system and it was found that the work for Punjabi has been done with a good accuracy value. Coming towards the conclusion, it was seen that preparation of speech, emotional corpus, feature extraction, selection, and classification are all important steps. So for this, we had created a Punjabi body emotional data set that was specifically done for the Punjabi language, which was a mixture of professional, non-professional, and online recordings. After that, pre-processing was done, then feature extraction, then feature selection done by less. So finally, the classification was done by 1D-CNN and the performance is shown in the form of precision recall, F1 score accuracy, and confusion matrix. Now, coming towards the future scope of this research, the ASP work can be extended by creating other type of data set rather than using the hybrid data set. Then more number of features can be added. We can use some other feature selection algorithms such as ANOVA, RFP, SFFS, or some other hybrid feature selection algorithm can also be employed. The network or the classifier can also be improved by using 2D or some LSTM layer can also be added in this so that the SER system for Punjabi can be further improved. Thank you.
Yes, Dr. Patil,
Yes, sir.
would you like to conclude the session?
Yeah, yes, sir.
Yes.
So we have total four papers, that is paper ID 141, 200, 221, and paper ID 228. Very good research is presented by the researchers here. The first one is about meta heuristic algorithm to solve the problem. The second one is about the class imbalance problem and is very much needed in machine learning and deep learning. So many times data is imbalanced and that is very well handled and that can be extended further. Explainable AI is the next researcher is working with, and uh, it's a good topic to work on. And the last paper is on uh, emotions recognition on speech regarding Punjabi language. And many researchers are working in this area. It's a good area to explore and a very good work by the researcher reported in the conference. Uh, the only thing I need to suggest here to the researchers is whatever the literature review you are doing and the research gaps you are identifying needs to be noted down, and that research gaps we need to solve so that your innovative work can be get published with good conferences and journals. Thank you. So thank you very much, Dr. Patel, for inviting me. Thank you. Yeah.
Dr. Patil, thank you very
Yes.
much for sparing your valuable time and coming here as like a session chair. Thank you very much, sir.
Thank you. Thank you.
Okay, sir. Dr. Kavesgar?
Yes, Dr. Patel, good morning.
Good morning. Shall we start earlier a little bit?
Uh, as you wish, I think everybody is here. If you don't mind, we can start.
Okay, so that you will get some more time.
I will see if I need more time or not. Thank you.
Okay, no problem. So our next, we have an invited talk, and for this invited talk, we have Dr. Mariam Kavesgar. She is working with School of Engineering and Applied Science, Ahmedabad University. Her area of research are mainly autonomous driving, active safety, mobile robotics, and sensor. And she is also editor-in-chief of IEEE ITS podcast. So I welcome you, Dr. Kavesgar, for this icSoftComp 2022.
Thank you so much, Dr. Patel, for your introduction. Can you see my screen? I'm sharing that.
Yes, you can see.
Okay. Thank you. So I start sharing my presentation. Is this visible?
Yes, visible.
Oh, that's great. So I was
If
told
possible,
that
then please turn on your camera.
a camera is on, I believe.
Okay. Okay, no.
Is it on? Can you see me?
Actually, I am not getting the screen of this participant. So
The
I cannot
camera is on.
see
It
any.
is visible, sir. It is visible.
Sir,
Visible.
visible, sir.
Okay, thank you so much. Thank you. So I'm going to talk about IV and ITS, and I would like to start my presentation or talk with a question that I have been asked frequently also whenever I say IV or autonomous driving or any type of driverless cars in India. And this smirk comes from everybody, or laughter, or a doubt that will this be possible? Even how, and many questions comes with that. So of course, with you know, coming of any new technology, we will have to face some changes and of course some hurdles. When Mr. Nitin Gadkari, the Minister of Transport, was questioned about autonomous driving or any type of high level of automation coming on Indian roads, he expressed his worries in few different points and hurdles which he discussed. One of them were jobs. He was worried that the society will have problem with losing jobs. He was worried that with coming of autonomous driving, many of the drivers of India, and there are a huge number of them, they will lose their jobs. However, there's a research in Bloomberg and published by Bloomberg about jobs of India and drivers. Of course, the talk is about overall around the world, that not only autonomous driving won't cause job loss, but on the other hand, they are going to create a lot of jobs, but in different fields. So we cannot be stuck to the traditions and rituals of decades ago, and we have to move forward. Another thing that he was very much worried about is infrastructure. And we all know that what is the situation of infrastructure on Indian roads. And many of the developing countries, that's why we have a separate section of intelligence transportation for developing countries. And infrastructure can cause lots of problems. It has to be solved, and it doesn't have any other way but going to be better. Indian motor vehicle rules, which last time was updated in 1988, even without autonomous driving, it needs an update and it has to be changed. In my presentation, after explaining all these worries, I want to discuss a few important matters And want to tell you that today my presentation, it's not very much technological based. We had enough talks and beautiful papers presented by students, and I want to share some conceptual and maybe a little bit of philosophical aspects to share with you about this problem that we are facing. So for that, I want to start my talk with a bitter truth, and explain to you that why actually we need autonomous driving, why we need, even not talking about autonomous driving, why we need more sophisticated and better performing ADAS, advanced driver assistance system. Then I will move to the tale of two town. When we are approaching research, especially this type of research, either we have to be human centric or technology centric. This was the trend before. But with one two slide that I want to tell you, and I want to show it with you, that we cannot approach our problems anymore either human centric or technology centric. The problems are changed. The same thing is happening with the papers that yesterday I spent some time listening to, beautiful research papers that was presented here, that were presented here, and today's also. I believe that in many of them that human centric is already included, but has to be discussed and be focused on a bit more. And of course, why should we consider AV? And those dollar signs give you a hint that why I'm going to talk about this. And this gives some guideline to our young researchers that how they have to choose their future plans for research. And of course, our problem statements in mobile robotics lab, which I'm going to introduce it to you as well. Let's start with the bitter truth. There is an interesting website if people who are here, they want to later look at it. It's called National Crime Records Bureau, NCRB. And in 2021, they published a very interesting statistic. Don't worry that it is too small. I have put a bigger version of it for you here to show you the problem. We had an increase in number of road accidents every year continuously. There was a nice drop in it in 2020, and everybody knows it's due to quarantine, very serious lockdown that we had in India. And of course, the road accidents had a good number of drop. However, as soon as the quarantine was over and people started coming on the roads, again, we had a drastic increase in the road accidents. The number that I'm showing you here is just road accidents. The traffic accidents, which includes different type of modes of traffic, it will show you higher number. From this, we can see that most of these accidents are caused by two-wheelers, normal cars, and pedestrians. Not truck and lorry and three-wheelers and other things. They come in a very smaller number. Very interesting talk I had once with Professor late Professor Mohan, and from IIT Delhi. And in one of his research, he showed actually one of the safest way of transport for school students is actually a three-wheeler rickshaw, which is showing the lowest number of accidents. As you can see here also in 2021 also, we had very few number of auto rickshaw accidents, and mainly accidents happen because of two-wheelers, four-wheelers, and pedestrians. Many of these, and almost 70% of these, are caused by human error. Some of them are caused by infrastructure. The last accidents that we had with Mr. Cyrus Mystery, and we know that how much infrastructure and the bad design of that divider had caused damage to the car, has to be addressed. And we can see that most of it was because of over speeding, dangerous careless driving, and some other small things. And you can see that how much it actually is caused by human. So this brings us to that question that do we need autonomous driving or not? Why we need it? Because based on sustainable transport, which is one of those few goals of UN, and followed by that European Union and many other countries, we are going to have triple vision zero by 2050. What is this triple vision zero? It means by 2050, we have a zero individual or companies affected by transport poverty. And mobility as a service is one of those things. We should not have any genre of society in India or anywhere in the world that they are deprived from some other advancements or developments because of transport. So this is a part that has to be fixed, and government is seriously working on it. And equity and equality, which I will tell you in one of our research that we are pointing at this. What do I mean by equity and equality? Zero deaths in accidents. This is very important, especially for countries like European countries. And India also is putting this as one of their major problem statements that they have to work on it. However, we have not reached the goal that even government has set for itself. If they had said that they're going to decrease the accidents by 10%, 20%, the result was 0.5. And this is documented in the, reports that they themselves have published. So one of the things that can help here for zero deaths in accident is automation, or ADAS or ADAS, and not only for the driver, but for the pedestrian too. So here we bring vehicle to infrastructure, vehicle to vehicle, and vehicle to pedestrian communication, and many other things inside the car, outside the car, to help to reduce this accidents, especially the fatality of accidents, to zero. And of course, one of the important things is zero emission, which electrification and other new resources are one of those approaches that governments all over the world, they want to take. Electrification, everybody knows that although they claim that it's a zero emission, it is not. It's close to zero, and lots of research and work is going to be done in this 2-3 fields. But I want to say something that just a bit, time ago, Indian government said that 2050 is very close for us for many of these goals, and they would like to stretch this deadline to 2070. However, we have promised that by 2050, at least we will reach some percentage of all these goals. So this makes the research in ADAS, autonomous vehicle, and communication for vehicles very important in this case. Autonomous vehicles are not something new. They started, people started developing autonomous vehicles when they start actually creating the first models of vehicles, first models of cars. In some research, they say that the history is not here, actually goes back all the way to Da Vinci, when Leonardo da Vinci designed actually a small car which could be controlled from a different place, but using different techniques. When this little car was developed, many countries were not ready to accept it even. It's not autonomous, it's absolutely manual. But roads were not ready for it, people were not ready for it. So it took some time that automobile, even the manual automobile, gets into our roads. Sorry for my dog barking. If you can hear it, I apologize for that.
It's fine, okay.
Yeah, thank you so much. This people started dreaming, and they put their dreams into systems of the car. However, after the inventions of electronics and electronic devices, computers, soft computing, machine learning, artificial intelligence, and we are going ahead in time, Now we have actually some cars with some levels of automation on the road. The picture that I have put here, everybody knows this car. Unlike what they claim, actually, these are not high level of automation. They are not L5, and they are stopped, and somewhere I will show you right now around L3. But people want to have an L5, and when they sit in this car, they think that it is an L5, level 5 of autonomy. Many companies and manufacturers around the world are working on this. Internationally, Tesla is one of the well-known ones, Waymo from Alphabet company, Volvo, which has started the first type of platooning trucks on the road. It started working on autonomous driving, and it actually provided one of the closest to perfect ADAS system on Volvo cars. Easy Mile, which producing shuttles, and its shuttles already running in many places in the world, including Singapore and all. Kamaz from Russia. Kamaz is very much working on heavy trucks. Kamaz is manufacturing heavy trucks and actually big vehicles, but they are focusing on heavy trucks. They're focusing on tractors. They're focusing on bigger vehicles. And recently we have Baidu. China didn't wait too long. If other countries spend years to create manufacturing plants for autonomous cars and technology for it, Baidu did it in 18 months, not more than that, with a very high speed and high accuracy. Same thing happens in India. We have Tata, which is a long time that they are working on this. TCS, Tata Elxsi, they started their work mainly in the beginning from UK, and then they moved it to India. We had many prominent scientists and researchers which developed this type of cars, and they gave their technology here. We have high-tech robotic systems, which also they are producing autonomous shuttles. And of course, we have Mahindra. Mahindra, same as Kamaz, is mainly focusing on heavy machine and tractors. Mahindra is focusing on automation of tractors to be used on farms and automation of farmings based on this. So many of you already know what are the levels of automation. These levels of automation are given as from the Society of Automotive Engineering. And as I said, Tesla is somewhere in level 3, but when people sit inside it as per dream, they want to behave like level 4 and level 5, watching some news, listening to music, reading their book. And for that, we had a couple of accidents happening for non-attentiveness of the driver. In India, automotive market, if is not the biggest in the world, is one of the biggest in the world. To compete in this race of autonomous driving has to be more active, both in small and heavy vehicles. And when I put those dollar signs over there, I'm talking about 8 to 10 billion in local and foreign investment. Now, the sales and the production of these cars cannot stand still. The technology has to move forward if we want to sell these cars to different countries. And India has promised that by 2030, will be one of the leaders in shared mobility. And shared mobility cannot happen without proper autonomous control system. But as we said, India is facing lots of infrastructure problems like potholes that mainly happen because of weather after the monsoon season, or for very drastic change of temperature, or no lining, no distinguishable traffic signs, which in both of these are technological research going on, collecting the data, gathering big data for machine learning and artificial intelligence in both these aspects. We have other helders. When we go on the road, we have different type of pedestrians. We don't have the pedestrians that people see in other parts of the world, because it is India, right? As before coming to India, for me, India was always incredible India. So we have Very different type of pedestrians on the road. A pedestrian who's pushing a cart, you cannot see this in Europe. You cannot see this in normal roads in, I don't know, somewhere in Frankfurt. But you saw, all of you have seen the video of Tesla, which is driving, and there's a carriage with horses in front of it, and the control system gets confused how it has to categorize this. It's a truck, it's a car, it's a person, and was a bit confused to categorize that obstacle in front of it. We have a different type of road users apart from humans. We have different type of animals which they already have caused some problem with the high-tech transport modes, which by rules and regulations government is trying to control it. And we have many different classes of road users and agents on the road. So if anybody has worked on transportation or intelligent transportation, you have seen that many of the software and simulators, they cannot simulate Indian roads because they don't have heterogeneous traffic system. They don't have three-wheelers, they don't have two-wheelers, they don't have bicycles and everything all together in the same line. They cannot give you no lining. They cannot tell you that if you have the cars waiting for the green light and bikes like little pebbles try to fill inside it. Which is one of the interesting research, that how we can model this type of traffic, not going with the classical methods that already exist. And many other things that I'm sure right now you're looking at this slide, you remember that if today or yesterday we're driving, there are other things that you can think about it. One more important thing that we should not forget is weather. Indian weather is very different. We have a harsh sun that can saturate our sensors and perception system. We have heavy rain that many of the perception, like LiDAR or even camera, they cannot give you proper input of what is happening on the road if you don't have if you have a heavy rain or harsh sun, and you will have a problem with this. So weather is one of those things that has to be specifically uh, researched and thought, and data for it has to be gathered in India to be used later for different parts of autonomous system. The picture that I have put for you here is an example of it. Marti is a Finnish car, which is the first car that could drive autonomously without a driver in blizzard. Before that, there was no other car that could drive and could find the path and pedestrians and other obstacles when there was a snow blizzard. Same thing has to happen in India, in Indian cities with their specific environment, geographical places, roads, and weather. So now let me tell you a little bit about myself after so much talking. I'm from Ahmedabad University and from a school of engineering and applied science. Not the one which has a running track on the rooftop, the one behind it, the red one. Somewhere I'm sitting then on the first floor, 112. If you would like to come, we have a very nice restaurant if you want to come have a chit chat and talk. In the School of Engineering and Applied Science, which we call it SEAS, we have recently, actually, it's about 1.5 years that we have started a research cluster just focusing on intelligent transportation. And the problem that I told you by now, there's just a handful of it. There are many more that can be discussed. And also, I'm handling a mobile robots lab, which we are working on a control system and perception for autonomous driving and any type of mobile robots which should drive autonomously. We are somewhere in downtown Ahmedabad, in the university area. You can later search our website to find out where we are placed. I want to tell you now about the research topics that we are looking at and the way that we are looking at this research. Fundament of research. Before, we already had tamed problems. Many of researchers here, they are familiar with these terms that I'm using. Tamed problem, it's not ready for the real world. And many of the papers that were discussed today also are like this. They are just talking from the technological aspect of it. When we bring it for the real world, this is called as wicked problem. This wicked problem was first, this term was coined by Ritter and Weber, Malvin Weber from University of Berkeley. They said that if we want to bring something to the real world, we cannot finish it in the lab and say, okay, it's ready, take it. Why it is like that? Because lots of human behavior is now involved. We have to predict using choices made by human, which sounds very familiar, right? The same thing that you are doing right now. There was a talk about a Punjabi. This is human behavior. You have to study the human behavior and then bring it into technology. So one very interesting outcome came from this Malvin Weber's and Rittel's work, A Wicked Problem. And Daniel McFadden used this human behavior and used this to bring it to BRTS system, BRT system, bus rapid transport system, and predicts that usually people based on their economic class, based on their education, what type of routes they will choose. In that case, we put more buses or we reduce the number of buses, and we will have a optimal system to with a minimum wastage or fuel consumption will give the best result. He ended up getting a Nobel Prize for it. So this is a very interesting topic if everybody was to look at. And as Professor Varia has said, the main problem in any traffic system is human behavior. If all the cars become autonomous without intervention of humans, and all of them they behave similarly, let's say as he says politely, we won't have a single traffic jam. Usually traffic jam or bottlenecks happen because of human behavior, which has to be studied if we want to bring autonomous cars on the road, on what level we want to do it. If they want to cross a crossroad, who is first, who's second, they have to decide between themselves. There is no I'm first, I go first. So basically, if we want to have hands off, feet off, and brain off, then we can get rid of this human bottleneck. However, it is not very possible. It is not, with humans sitting in the car and having the steering wheel late for his lecture, it might not very much possible. So as I explained, it's a tale of two towns, technology-centric and human-centric, which sensors control dynamic connectivity communication, some examples of technology, and human-centered behavior. Driver, even will they accept it or not? Pedestrian, will they trust the autonomous car on the road or not? Jobs, society, insurance, regulatory advisory, and traffic rules, they have to be adapted based on the new technology which is going to come. So that's why it is a very much multidisciplinary research. That's why here, as an engineer, I cannot sit in my room and work in my lab and come out and give the technology. I should have my colleagues from psychology group, from design group, from neuroscience group to sit with me, discuss this, and prepare a technology as a wicked problem. The same happens in traffic safety. Traffic safety usually is divided in three different parts. It's a pre-crash, crash, and post-crash. Recently, the same case with Mr. Mystery that happened, you can understand that pre-crash could have some signals, crash could have some help to reduce the morbidity and fatality that can cause the passengers, and of course post crash. And if we want to develop to this to the point that can be used as a mass production, we have to consider human behavior in between. In our lab, in my group, one of the projects that we are working on it is pedestrian driver interaction. So we have to predictive inequity in object detection. And what do I mean by that? In Georgia Tech, sometimes back, there was a research going on based on the artificial intelligence that they have and the models that they are using for autonomous driving. And they understood that 8 AI system of object detection system, if they be combined with a Fitzpatrick skin type, they show 5% drop in the darkened skin. Fitzpatrick skin type is the level of skin colors in different races, and because of some problem that you can guess, I will give you right now what was the reason. AI couldn't detect Afro-American in the US because of their skin color, 5% less than white people. And the reason was nothing, just data. They had less data about those people. If Tesla wants to come and work in China, in India, in other places, has to fix this data input from it. So we had to add more data of different skin colors and more weight accuracy for detecting. Another example was the perfect Volvo, which many of you have seen it. They took this Volvo to Australia, and Volvo stopped working as soon as it saw a kangaroo on the road. The same case that happened with Tesla. So the system just hung. It could not recognize what is this on the road. Should I go over it? Should I stop? What should I do exactly? So we are focusing on this problem on Indian roads. These pictures that I'm showing for you, they're all from Ahmedabad. We gathered lots of data. The data set is almost ready. We have put bonding boxes around the pedestrian, and our main focus is from the egocentric point of view. We are putting camera inside the car, and we are looking what the driver or future AI system will see: different weathers, different time of the day, different types of people in different places. At the moment, our focus is only on urban area. However, this study should be expanded in more different places. One of the things that we had problem with it is actually this lady and his fruit cart, which normal softwares could not detect it as a pedestrian. So we have to a little bit tweak the programs. And this is a late, just a few weeks back, I got it. It's exactly on the SP Ring Road. This person was pushing his cart where cars are driving with 80, 90 speeds. So we had this problem. So we gathered this data, we put them all together, we made a list of all the crepes, we created a list of events, crossing or not crossing. If it is crossing, why it is happening, why it is not happening. Apart from that, we had in more populated area, we had people which not crossing, but they are going along the street. So this was one of the interesting things that happened. So we started our annotation. Annotation cannot happen if we are focusing on so many different things with the normal tools that are available. Also for attributes, because these things that we have, they are mainly for European groups. Here we have very different things that we have to add to annotation and attributes. We have another research which is going on, and I would like to talk about it, is two-wheeler driver behavior. This is one of those researches that we didn't do it just as engineers. This is a group of three of us. Dr. Fenil Shah from Design Lab, Professor Urmi Biswas from Psychology, and I am there from Engineering, and we are focusing on two-wheeler safety. Based on the statistic that you can see on my slide, the main part that we are focusing on at that age group between 5 to 29, 73% of accidents are caused or hurt this group. And this is a young group. We are moving forward. India is lucky that it's a young country, so we have to protect this group. So based on the data that we have found, every 24 seconds, somebody is dying because of accident. So we focused on this age group, and we were lucky we are in the university, so we sent the questionnaire to all our students. We gathered a good amount of data. So our age group will be focused on 17 to 24. It's some sort of a pilot study that we did. And we gathered the data with many different type of questions about four-wheeler and two-wheelers. Many different type of questions, because we were not sure actually how it would be different from the previous researches that have been done, for example, in Europe. They have done lots of research on this, but the gap is very much visible here. And we got some surprising results. We got some counterintuitive results. We understood that listening to loud music is not an auditory cognitive problem. Looking at GPS when it is placed properly on the screen, it doesn't call visual manual problem. Visual manual and auditory cognitive are two different things that can cause accident. But those students which have to stop and listen, or they have to stop and look at their GPS, they have some accident. From home they learn driving. We understood that those group of students that they learn driving from their parents or their drivers, they had less number of accidents compared to those students who have gone actually to driving schools. So this brings a question: what is happening on our driving schools? We had gender. Unlike what everybody's gender biased about this, we understood that females, they are having less accidents here. I don't know how many of our scientists and researchers here are female girls or women. I'm happy to share this with you. And where do you place your navigation device? It showed a big difference of those people who had accident, who didn't have accident. We are still working on this. We are taking it a few steps forward with adding some sensors and driving behavior. I know I talked a lot. Just in a few minutes, I will finish it. I just want to tell you that for this type of research, even for we are in the conference of soft computing, and I see many different things. Yesterday, Professor Pratihar was talking about that robotic soldier. We have to discuss about ethnography, demography, and geographic studies in holistic approach, right? We cannot separate them together. So big data, ML, AI, communication, control system, if they want to come together, we have to consider one important point here, and that's human behavior. And India, such a big country, has different types of behavior. Solution, we already talked about this. We have to data. We have to gather more data about the environment that we are living in it, and we are providing this solution. Will autonomous driving solve the traffic problem? Not necessarily. Based on the research done in Australia, human behavior has a big effect here. People want to have a car, people don't want to share their cars, and their attachment to conventional vehicle is very strong yet, but it will take time, so it needs some work. I chose this topic because, as the statistic given below, the industry of $5 billion of driverless car is going to reach $285 billion very soon, most probably in the next few years. This is part of the activity that we have. We have a test track for AI algorithms. I don't know if it will start. Oh, it's starting here. This is the first car which our students made with a very primitive system, not very good encoders and all. I think they chose the right song for it, and it's not going to be the same as it was. Everything is going to change. And that track, if you want to use it, you are very much welcome. We have a traffic signal, we have GPS sets in the lab, which will give you the data of the positioning. We have traffic signals, traffic signs, and whatever you make in your AI system, you can test it actually on the track. That was the urban track. We have some country track also, which gives a more narrow turns and everything. So as Dr. Patton mentioned, I'm a member of IEEE, and I'm a producer of RTS podcast. If you want to talk about your research, if you want to be volunteer, if you want to share something, please drop me an email in any of this, or you just want to talk about some research. Let me know. I will be happy to reply to you. Thank you so much for your patience.
Thank you very much, Dr. Kavesgar. Participant, if you have any questions or query, you may ask. If anyone has any kind of a question or query, then you may ask. No question?
I hope it was not that boring, Dr. Patel.
No, no, it's not boring. Actually, you have proposed so many research thesis like kind of thing, or many areas that you have covered. Like it's a very wide
Yes,
area
it
of
is.
research over here. And this is really useful for this emerging as well as the accomplished research scholars. These are really interesting area of working for for a research. But I don't know why any participant have any kind of
That's
question.
okay, but I have shared my email. If you would like to take any discussion offline, please let me know.
But I have one question, Dr.
Yes,
Kavis.
please.
You work so means you have spare so many times for like studying in behavior of the Ahmedabad means drivers and humans. So, do you think that are we are ready for this autonomous vehicle? As
Sorry, I didn't get the end of your question.
are Indian ready for this autonomous vehicle?
Uh, uh, Dr. Potter, that was the first thing that I said. They are going to be ready, and the same way that vehicles opened their ways on our road in 19 maybe 11, 1912, 1920, this will happen soon. At the moment, maybe we are not ready. At the moment, we've actually noticed that many pedestrians, they don't dare to cross the road, and but this has to be changed, and it will be changed. So that is my prediction for future. At the moment, I won't say that it is ready.
Because there are so many aspects in this thing. The main aspect is like we have a political parties. They don't have the same kind of. They are not agree with each other. And
Yes, I think we can discuss this later. But the political parties, they are mainly ruled by those dollar signs which I was sharing with you. That's my prediction. The same thing happened with many other technology. Even with EV, we had the same situation. EV was there before also, but because of money and fuel money and oil money, many companies were not ready to accept it. But now they have to. Now they have to move slowly towards EV or
right.
something replacing it. But yes, you are absolutely right. There are many different factors involved in this, because that's what I said. It's a very multidisciplinary research field.
Right. And one more thing that do you think that the in India we should have academia industry collaboration for this autonomous vehicle?
We already have, Dr. Patel. As I said, TCS, even TCS in Ahmedabad, Tata Consultancy Services, they have already started working on this. And there are many startups which are working on this field. And I would like to suggest maybe next time when there is any symposium or conference about intelligence vehicles, those who are interested can see that how many startups are actually focusing on this problem, and in different aspects. And yes, many big companies are already investing on this projects. They don't jump directly to autonomous driving, and they are starting from very complicated ADAS systems, and then slowly move to autonomous driving. But as I said, like Mahindra is already working on autonomous tractors. They're working on autonomous between states truck, interstate trucks. So hopefully we will have a more adequate and in order traffic rules and traffic roads ready for this technology.
Okay, thank you very much, Dr. Kavesgar, for sparing your valuable time and taking this very good, very informative and very thought-provoking this talk to us, given to us. Thank you very much, sir. And
Thank you
thank you.
so much. Thank you for having me.
Bye. Uh, Dr. Kaveskar, are you there?
Yes, yes, I'm still here.
One question is in like a chat box. Is there any research going on in the area of autonomous railway transportation?
There are lots of research going on actually on railway transportation. Uh, One of the first transport modes which started having this thought of being autonomous, being driverless, one of the first one was actually train transportation or railway transportation. And the reason for it, first of all, most of the track is in a it's as we call it, it's a structured environment. It's constraints. There are, especially in European countries, there are sometimes fences around it. There is no different type of decision making for the train. When the car is on the road, it has to decide from point A to point A, where I have to turn. Should I take this road? Should I take that road? But however, in the train, we don't have this. Yes, there are lots of research and many already available autonomous trains in the world. The person who asked me, I don't know, but maybe as a suggestion, maybe you take a look at that train which is moving from, I believe, from Baroda to Mumbai, and had few incidents with kettles on the road, and they have decided to put a fence around it. That's a very nice topic for you to work on it.
Right. Right. Thank you very much,
Thank
Dr.
you.
Yes. Dr. Parikh. Dr. Sorin Parikh, are you there?
Hi, hello, Dr. Patel. Can you hear me?
Yes, we can hear you.
Okay. Yes, thank you.
I
Very
made
good
you the
morning.
presenter. A very good morning. Good morning. I made you the presenter so you can share your PPT.
Great, sir. Okay. Just give me a moment. Yes, I'll be sharing it.
So meanwhile, let me introduce you. So our next speaker is Dr. Sorin Parikh. He is working with Institute of Technology, Nirma University, Ahmedabad. His area of research are machine learning, computer vision, and human-computer interaction. The title of this talk is Machine Learning Approach for Predicting Levels of Learning with Eye Tracking. I welcome you, Dr. Parikh, to this icSoftComp 2022.
Hi, do you see my screen, Dr. Patel?
Yes, yes, we can see.
Okay, great. I'll be starting the slideshow.
Right.
Okay, great.
Welcome, sir. You can start.
Thank you, sir, for the introduction and for the invite. And good morning to all the delegates at the conference. It's a pleasure talking to you. I'm Saurin, as sir said. I work at Nirma University as an associate professor. Today, my talk here at the conference is on machine learning approach for predicting levels of learning with eye tracking. I'm sure you had a fantastic experience at both the days here at the conference. Hopefully, I'll be able to ignite the same interest in this area too. So I offer my prayer to Almighty, and we start with prayers. This is the Nirma University campus where I work at. If you get a chance, please do visit us someday. This is my problem statement. So, friends, post-COVID, e-learning is transforming the delivery method of education. We know today millions of students are taking self-paced online courses. However, we know that the content and language complexity often hinders comprehension. And without the lack of, or without the immediate help from the instructor, it leads to lower learning outcomes. So, the ability to predict difficult content in real time enables e-learning systems to adapt content as per the student's e-learning level of learning and assist in learning. So this was the problem which we faced, that whenever the student is reading the slide, a text slide on a online course, the teacher is not immediately able to measure the level of learning. So the adaptive e-learning cannot take place. So the simplest example is if even a word comprehension even a one novel word can hinder the comprehension. So if we know the level of learning for the slide, the subsequent learning can be adaptive in nature. So that said, that was the problem statement. Now the main challenge is how to predict the perceived difficult content and the student's level of learning in real time. We say sometimes the eyes can say more than the words. And we built this we did this hypothesis and we did this work a couple of years before. Uh, we say that eye gaze and pupil response and the variation in the response to the same visual element or text over time indicates students' level of learning. What is the research motivation to use eye responses as input for predicting levels of learning? You see, this data which we collected from this particular source, it says that course completion rate of low-income students is only 25%, but non-native English-speaking students are taking this online course. The major issue is the level of learning, the comprehension, we are never able to measure it. So, the subsequent design of the course can never change without knowing the level of learning from different class of users. So you see the course completion rate is always low. The other motivation is low-cost eye trackers coming up and the ability of this tracker to record eye response on the visual element or concept in real time. So, when we are reading a passage or paragraph on a slide, where we look, when we look, why we look, how long we look, does matter to solve the task or learning exercise. Today, we have different types of eye trackers available in the market, different category of eye trackers. The first one here is shown in the list is a wearable eye tracker, which is the wearable eye tracker is normally designed to capture natural viewing behavior in real time. So, the human subject does not have to be stationary at one place. He can move around and undertake the tasks, wherein we can measure the eye and pupil response in real time. The other one, which is used mostly in research, the other two are mostly used in research, in the research labs in particular, is the screen-based eye tracker, and the compact one is a Tobii Pro X260 Nano. The last one, which normally captures gaze data at 60 hertz and is suitable for studies outside of the lab also. It's designed for fixation-based research. So I did work upon this particular eye tracker. These are the eye tracker companies which are manufacturing this particular trackers, and mostly they are available in India too. So I've been working with Tobii Pro. So I'm explaining here the working of the eye tracker X260 used for this research study. We see normally the tracker is mounted at the bottom of the screen as shown here. Let me start the pointer. So it's mounted at the bottom of the screen here, and an eye tracker consists of a camera, illuminators, and algorithms. So the illuminator, you see these red dots, creates a pattern of near infrared light on the eyes. And the cameras, which are deployed in this eye tracker, takes high resolution images of the user eyes and the patterns. And the image processing algorithm finds specific details in the user eye and the reflection pattern. So that said, based on these details, the image processing algorithm will find the exact gaze point in the visual field where the person is fixating at. Right, so this gaze point as shown here is where the person is fixating at. So this algorithm will naturally compute the eye position, gaze point, and the pupil diameter at the particular point of time. So this is how normally the eye tracker works. Now, with the help using the eye tracker, we can naturally collect the gaze points. It means the fixations, where the person is looking at, how long he's looking at. But how to analyze the data? There are some open source tools also available in the market. So an open source software which we normally use in the lab is Agama. This is the analytics eye response analytics tool, which from this analytics tool, it has various modules like fixation module, attention map module. I just use fixation map module here to show you what we receive. Normally using this tool, this is the scan path of the user who read this passage or this paragraph, right? This is the scan path. So the red color dots are the fixations, or the red color numbers are the fixations. And the number indicates the scan path. And the yellow lines are the saccade, which shows the of the movement of the gaze from one position to the other, or from one gaze point to the other gaze point. So we receive this fixation module, and with the help of the attention map module, we can also look at where in the entire slide the user have fixated on, right? So this red color indicates the higher attention areas or the region of interest. So the color code is that the green represents the less interest areas and the red represents the higher interest areas. So here in this paragraph, the red has the novel word carnivorous. So this indicates the subjects, human subjects interest. This helps us to look at the experiment results, to analyze the results. But however, we want to build a predictive model, so we are interested in the raw features or the low-level features. So what we did is we did structure. So this was a general setup, a structure of our experiment in order to learn about, in order to conduct our fixation-based research. Here, the general experiment setup here is the human subject sits at the 30-inch away from the monitor where the eye tracker is mounted, and Ogama is connected here to the tracker. Ogama does what? It records in real time the eye responses, pupil responses of the user when he reads the passage, and we receive this raw data, raw pupil and gaze data. So this gaze data is the fixation start time. Fixation, it means where the particular person is fixating at a particular point of time. And then the fixation length, that's the duration, and the fixation coordinates, that's the X and Y coordinates on the screen. At the same time, we also receive the pupil diameter. At the particular fixation, several samples are collected, and we normally receive the pupil response for every millisecond, as for example. So the pupil diameter is also received. We call that as a raw pupil data and the gaze data. Then we created this engine here, we called as our module, where we extract the words from our slides and overlay the gaze data on it. So for every word in the slide, we have a term eye response map. So for every word, we have eye response map, which has various features. We have handcrafted 16 features, which I'm going to show to you. And then we collected the data for every experiment. And then we trained our machine learning model. And I'm going to discuss about the entire machine learning model, which we developed. So we have this term eye response map for every word on the slide. So this is our word eye response tracker, which we built. And our general experiment setup was that every instruction slide was followed by passage, paragraph, or a sentence slide. And because we were studying the reading and we wanted to predict the level of learning while reading passage or paragraph. So, then was followed by question slides also. So this is in the order in which every experiment was conducted. And the font size, which we had kept uniform on every slide. Total, we did experiment in 2 phases. First 10 human subjects, and then 25 human subjects participated in the study. And here at the bottom, I'm showing you what we receive normally, the expanded view of a slide. You can see here the dots here represents this particular 1, 2, and 3. It represents fixations. And the yellow color lines are the saccade. So fixation number 8 and 9, they're the subsequent fixations, right? So that said, I'm going to move on. We conducted various experiments, so I cannot go through all, but I'm going to try to take you through most of the experiments. The first experiment we conducted was to measure the word familiarity. We wanted to understand whether word morphemic complexity does influence the number of fixations on a word, because every word, we wanted to learn that every word would receive single fixation, multiple fixations. How many fixations? Do we fixate on every word while we are reading a paragraph? Those were the open questions. So to understand, we did run our various experiments with the new trackers which are available in the market. So, this experiment, the objective was to learn about word morphemic complexity, word familiarity, eye responses on a word. So let's look at this kind of a passage was shown to the users. And let's look at where do we look and why, how does it work? So you see, all of you must be familiar about the visual field and the acuity. Whenever a passage is shown to the user like this, we fixate at a particular region of interest in the passage. Let's say the center word here. So when we fix it means we are bringing the fovea onto that region. So we call this region as the foveal region, and the surrounding area is the parafoveal region, and the outer circle is the peripheral region. So you see your visual acuity is the higher in the foveal region, then the peripheral region. As we move from the foveal to the peripheral region, the visual acuity reduces. So this shows the visual angles which are created when you fixate your gaze at a particular point and bring your fovea into the specific area. So let's look at the relationship between fovea, foveal region, visual angle, and the line of sight. This is your eye, and at the back, inside the eyeball, this is the retina. Small pit here is called as a fovea, which is only of 1.5 mm. Now, let's say the human eye is at a distance of 762 mm, and the letter in the visual field, he's just fixating upon one letter where the height of the letter is 27 mm. This is just for example, just for our understanding. The height of the letter is 27 mm and is human eye is at a distance of 762 mm. Now, this is our pupil, this is our cornea. Now, this particular letter would fall inverted onto the fovea. Correct, because we bring our fovea onto this word and fix it on it, and this word falls on the fovea. So the visual angle here created is 2-degree visual angle. Any word beyond this letter on the left-hand side would be in the parafoveal region. So I'm going to skip this slide because we cannot go through this low-level details. So the second, here this slide shows the meaning of the term fixations. Here you can see the subject has read the slide. So these fixation numbers are the scan path. These are the sequence of fixations while the person read this particular slide. So fixation number 15 and 16, and the white line shows the Saccard length. So the Saccard length here between two fixations, 15 and 16, is only 4 letters. So, which are the factors causing multiple fixations and variable length Saccards? Word structure, right? Let's look at the word structure. These are the low-level features. What we consider is word fixation. The number of fixations on a word depends upon various low-level features like morphemic complexity, pronunciation difficulty. High level we consider as word familiarity and contextual ambiguity. Let's look at the word structure. Word is normally an aggregation of morphemes. What are morphemes? Morphemes are smallest meaningful unit of a language. So once you segment that word, it will discard the meaning. So like book, it cannot be broken down further. So this is as per the British English, right? And so morphemes are of two types, bound morpheme, standalone morpheme. So here, let's say the word non-perishable. As per the British English, the word perish is a standalone morpheme, whereas the word non is a bound morpheme. So bound morphemes cannot stand alone, need support of a free morpheme in order to have a specific meaning, to change the meaning of the standalone morpheme. So when we say parish, parish has a meaning. Then we say non-parish, the meaning may slightly alter. So non and able are bound morphemes and parish the standalone morpheme. Now, again, for every morpheme, when you try to read that morpheme of the word, normally, we try to break it down into syllables, and every syllabus is like when you twist our tongue, to pronounce that specific syllabus from the morpheme. So it's a unit of organization from the sequence of speech sounds. So walk, turn. Naturally, these are two speech sounds. So every word has specific number of syllables depending upon the speech sounds. So the syllable here is non-perishable. It has 5 syllables and the morpheme is 3. So that said, we consider that these factors do affect the word structure, do affect the number of fixations on a word. And the fixations are very important for us to learn the level of learning for the word and eventually for the sentence and the paragraph. So what we see is how do we read a word, correct? So as shown here, the word psycholinguistic theory, we have shown 3 fixations, 1, 2, and 3. So if you see when I'm fixating here on during the first fixation, the human subject normally receives a left preview benefit and a right preview benefit. It means the 3 letters on the left, 5 letters on the right fall in the parafoveal region. So that is what I can read due to the parafoveal on-foveal effect, which is we call as. So during this fixation, actually, normally the human subject is able to preview both the 3 letters on the left and 5 letters on the right. This is as per Dr. Keith Rayner. And this left preview and right preview benefit vary from subject to subject. Every subject some subject may have a larger preview benefit, some have a shorter. So when you are a new language learner, you have a shorter preview benefit. But when you have a skilled reader, you have a larger preview benefit, and most of the time. And if you are from the Arabic world, you normally have a larger left preview benefit than the right, because normally you read from left to right there. So you see, during this fixation, we measure the fixation duration. And during for this entire word, we had two fixations, and we measure the gaze duration. That is the sum of the fixation of all the fixation on that word. So we also measure the gaze duration, fixation duration of each fixation, and the number of fixations on a word. So now every word also in our study, we categorized into one of the 9 classes based upon the word frequency and the word length. Every word we have divided into 3 categories. That is a big, that is greater than 8 letters, and mid-size word and small-size words. And word frequency, we have 3 types of class: low frequency word, high frequency, and we consider as common words. Common words are the stop words. And high frequency is as per the word corpus, and low frequency is also as per the word corpus. Like here we will use the contemporary corpus of American English in order to derive the frequency for every word in the word study. So psycholinguistics and theory. So the psycholinguistic word as per the corpus is the low frequency word. So the class for this word is low frequency big word. And this is word high frequency mid word. Why am I saying this? These are the various features which we are collecting. We are collecting the eye response features and the word structure features. So that said, I'm going to move forward. So from here, we main takeaways is we learned about fixation, sacchards, and preview benefit. And we created 9 class of 9 category of word classes. So every word in our study belonged to any one of this class. So as per the father of eye tracking based research, Dr. Rayner, he had given this that hey, skilled oral readers skilled readers while doing oral reading normally would have fixation on word of length greater than 8 letters. Mean fixation duration is this. Fixation duration would range from 50 to 600 milliseconds, depending upon the familiarity of the word. The saccard length would also vary from 1 letter space to 10 to 15 letter space. Saccard length means the distance with the user moves the gaze in and fixates to the new region of interest. So that number of letters in between the 2 fixations is normally termed as a saccard length. I already explained that earlier. And the average saccard length would be 6 to 7 letters. When you're doing oral reading, now you normally take more time to read, and naturally your saccard length would always be shorter. While you do silent reading, you have a larger saccard length and you read faster. So as you can see here, the mean fixation duration for silent readers is less. So however, this is just a general guideline, whereas we consider reading as individual characteristics. Hence, we need to measure the reading characteristic of every user. As you can see here at the bottom of the screen, the word tracker had no fixation, whereas the person during the oral reading did read the word tracker. So during his fixation number 6 here, he had the preview benefit for the word tracker and naturally had read the word tracker even without fixating on it. So that we try to do this experiment setup where to understand the number of fixations which will be received on a word. So you can see here, we from the word corpus, we collected all low frequency words. So we showed the target words to the subject, and then we asked them to answer the word meaning question. And thereafter, we collected the eye responses on the word were recorded. We call that as first pass eye response features on the word. So here the word mellifluous was shown. And as you can see, mellifluous has 2 morphemes and 4 syllables. So then after we had asked the user to answer the meaning question for the word. I'm going to show, this is the result, and this table shows the result. I'm not going to read everything. I'll just show you one thing from it. You can see here subject H9 on the word mellifluous has approximately 4 fixations on every syllable. So he reads at the syllable level. You see subject subject H4 has only 1 fixation on the word. He normally is reading at a word level. And we had subject H13 or any other, let's say this subject H7 or H13 only having 2 fixations. These reads at the morpheme level because the word has 2 morphemes. So the point is that we measured that the preview benefit and the saccard length and the number of fixations on the word was varying for every reader. And the readers were belonging to 2 categories, non-native English speakers, and native English speakers who are from the English background. So we observed that the reading characteristic did change and everyone had their own properties. So next is anticipatory behavior modeling. Now, words we never read in isolation. We always put words in the sentence, and we are reading sentences when we are trying to interpret the sentence. So the next study was about anticipatory behavioral modeling. Why word is not fixed? That was the main question. So there are these three control models, which I'm not going in detail today, but we are looking at Rayner's model, where Rayner said that the word familiarity and the working of the long-term memory or the working memory does affect the number of fixations and whether the word receives a fixation. And anticipation based on context also would drive the saccadic movement of the user. So here you can see what we consider in this at the bottom. There's a sentence here which says application of eye trackers in psycholinguistic. The word tracker, no fixation. When you in context of fixation number 6 here, the word I is a foveal word and the word tracker is a parafoveal word. And next to the parafoveal word in the peripheral region normally is the word psycholinguistic. So in context of the fixation 6, we did some, in context of fixation 6, I'm going to explain you something. You see what happens normally while we consider when we read during fixation number 6, when we read the particular word I, the word tracker is in my parafoveal region. So you see what happens? Bottom-up processing happens here. The eyes look at the region of interest. The fovea receives the visual signal from the region of interest. It means the word I. And due to the parafoveal on-foveal effect, would also receive the word tracker. However, his fixation is on the word I. So the word foveal, the fovea receives the visual signal of the from the region of interest. The visual signal is sent to the visual cortex for where the user perceives the word. So let's the word is perceived as I, and thereafter the next visual input is automatically anticipated. Right? We anticipate the next visual input even before moving the gaze to that word tracker. And the perceived signal would now control the saccadic movement of the eye. So now if the anticipated word is, the word is anticipated, even before we moved our gaze from the fixation 6 to the next fixation. So then when we move the gaze to the next word, here we make a short pause. And if the word, we again now receive the visual signal, that is the word tracker. During the short pause, if the word matches our anticipation, the reader quickly moves the gaze to the next word. So this is considered as anticipatory behavior or anticipatory behavior modeling. So due to the anticipation, if the parafoveal word is matched, then the parafoveal word is skipped and the gaze moves to the next word after the parafoveal word. And if that is, it does not match, if the user had anticipated something else, then the normal behavior of the reader is to do a backward saccade. He'll move the gaze back to the start of the word or to the start of the sentence or to the start of the phrase. So in that case, the reader does a backward saccade to the previous word if the anticipated word does not match with the next visual input, right? So we'll receive. So that said, this diagram or this slide, this is the main takeaway. So now here you will ask me that during the short pause, why it is not recorded as a fixation? Because there is a particular theory when to record a fixation. Based upon that, I cannot go in that lower level details. Because of that, the trackers would not plot this as a separate fixation, right? But due to this reason, tracker did not receive the fixation because of the anticipatory behavior modeling part. So we all anticipate the upcoming input, and even in the Google search engine, we normally see that the same the brain function has been implemented. When you type in the word in the search, the next words are suggested to you because it's anticipating the upcoming visual input. Same thing we also do, right? The To test whether this works, we did an anticipatory behavioral experiment. In this paragraph, what we did is only focus upon this red box. In this paragraph, in this red box, hand eye is our foveal word, right? And parafoveal is disorientation is going to be our parafoveal word. So when the user, after reading the previous two lines, fixates on this foveal word, right? Our interest is to check whether anticipation did occur and did the subject did anticipate about the upcoming input. So what we have done here is actually the right word here in this context was hand-eye coordination. We replaced the word coordination with a related antonym, which is disorientation. So, whenever any subject, human subject will read the passage and will come and will fix it on the hand eye, then anticipation occurs before moving the gaze to the next word, that is actual word after the foveal word, before moving the gaze, he would anticipation occurs and he will anticipate the word as coordination based upon the contextual reading which has taken place. But when he finds the word disorientation instead of coordination, it means it's a mismatch with the anticipation which occurred. Because the next visual, he'll move the gaze from hand eye to disorientation, and he will receive the word disorientation instead of coordination. So what our hypothesis is, in that case, the backward saccade will occur where the user may move the gaze to the start of the word at the start of the sentence, right? And this is again a reading pattern. So here, what we expected is reader reads foveal word and anticipates next word. Upcoming visual input does not match, so backward saccade to the previous word may take place. That said, we actually studied. You can see here this box. Now the white rings which will appear here uh, on every fixation number is the forward saccade. And the yellow color is the backward saccade, which takes place because of the anticipation mismatch. So you are seeing the backward saccade took place. After looking at disorientation here, the backward saccade took place at the start of the word, and this yellow rings represent the backward saccade. The fixation numbers helps us to know whether which one was a forward saccade or the backward saccade. So this is how anticipation mismatch triggered a backward saccade, which is like a reading pattern. Now what we did is, I'm going to skip this experiment about pupil response and go to the next one. So the main takeaway is word may receive a fixation, multiple fixation, or no fixation. Saccade length may vary from 1 letter space to 12 to 15 letter spaces. Preview benefit also may vary from 1 letter to 5 letter spaces on left side to 3 to right 9 letters on the right side. First fixation may land anywhere on the word because anticipation drives the next saccadic moment. Word familiarity does influence the number of fixations on a word. Fixation duration varies based upon the familiarity of the word, and the context reading may cause a refixation on a word, which we saw just the refixation happening. And these are the various factors which, hence, we consider that reading is an individual characteristic driven by following factors which plays the role, right? So next set, we handcrafted this first pass eye response features, and we were not the first one. Many others had handcrafted some of the features from this list. So the single fixation duration, first fixation duration, gaze duration, fixation count, mean pupil diameters on left and right eye, and saccade length. We considered this as first pass eye response feature. What is first pass? When I read a word or a sentence first time, right? Because eye responses collected during that is considered as a first pass features. Now, reading, we don't while we're reading a sentence or a paragraph, and we perceive when we read a novel word, right? When a word is perceived as novel, it means we don't know the meaning. So on first look does not always remain novel. So whatever we read the word on the first time does not always remain novel. When I say first pass, it means when the sentence or the paragraph appeared in front of me and I'm reading that word and I perceive that word as novel. I don't know the meaning. It does not always stay novel because readers make an effort to derive the meaning of the novel word by looking at its information context. So information context does play a role. So what we believe is in the information context may help to derive the meaning. So the word can be learned, right? So it's not always binary, that novel or not familiar. It can be learned from the context. So information context may follow or precede a novel word, right? And context may be related sometimes. It helps to derive the meaning. Sometimes it can be neutral. It doesn't have to derive the meaning. So that said, Chapin also had studied this, but we used additional features and tried to rerun some of the experiment. We created for our sentence, right? What we did is the sentence or the paragraph had novel word, and the context in this case was related context follows the novel word. So this first example I'm showing is this table shows me information context processing scenarios where I have the term, class, and context category. And we created 6 categories and sample sentences are shown here. I'm going to show you one category where in the sentence, the word is novel. So if you read this sentence, because he was convinced of his infallibility. Infallibility, as per the word corpus, is a novel word. Thereafter, a related context follows. Related means it helps me to derive the meaning of the word infallibility. The context which follows, this information context which follows is Adam never acknowledged his mistakes. It helps me to learn that, yeah, it's something which is related to the person is fallible means doesn't want to accept mistakes, right? So this was helping me to derive the meaning. So this category is novel related follows. We derived 6 categories as listed here, right? And using these categories, what we were expecting is reader does reanalysis of context and target word to derive the meaning of the novel word. It means when he does reanalysis, he's going to do a backward second, reread the word or the sentence. We consider this as a regression behavior, and regression is also modeled as a feature here. So that said, we extracted 3 patterns from this information context processing theory. We call it as loop back, find detail, loop back, regress, determinism. So you see, I'm going to explain you one. While person is reading the paragraph, I zoomed in into 2 words only. Yes.
Could you please
Yes, sir.
your talk?
Time is running out. So I'm going to go to the model and then show the result. 5 more minutes only.
Okay, no.
So these are some of the reading patterns which we extracted. And I'm going to skip some of the slides here. What we received is these 16 features. So every word, we had first pass features. We have reanalysis feature for the word and the structural features of the word. So these are the 16 features which we handcrafted. So every word would have 16 features. Now, this was our spatio-temporal response model which we created. And this is the data collection phase and the data pre-processing module. This is the training module, and this is the prediction module. So this training engine and the prediction engine, which we created. Now, I'm not going into the detail, but if anybody is interested, can always ask me more about it, and I'm going to share the paper if you're interested. Now, we are using this term response map. That's our data, the training data. So what we did is, I'm going to skip some of the slides. Sorry for that.
There are many slides.
Yeah, so this is the slide which I wanted to show you. In the training phase, we showed them the passages, and then we asked them the questions. So in the training phase, most of the words in the passage were high frequency word. It means high familiar words. But during the prediction phase, the passage had words from all category. So this is our model, and I'll directly go to the result. So this was our model. This is the training phase, the prediction phase. So when we the result of our classifier, the feature weighted linguistic classifier, we saw when we used feature selection method relief, our feature weighted linguistic classifier assigns weights to the features. So when we were using relief as a feature weight, as a feature selection method, we had used relief, information gain, and ensemble method. So, we saw the prediction accuracy of 90% and ranging from 89 to 90%. We ran these experiments first time with 10 subjects, next time with 25 subjects. We received the prediction accuracy ranging from 90 to 92%. Now, true positive rate is of more interest to us because a word which is perceived as novel by the subject should be predicted as novel. So true positive rate should be higher. So with our baseline classifier, which was majority voting, the accuracy was only 60%, but the majority voting had a lower true positive rate. It means it was not good at predicting novel words. But for information gain with our feature weighted linguistic classifier, the true positive rate was 82% and the accuracy was 92%. We have tested with this model with various different experiments conducted thereafter. Because what we did is we did hypothesis testing to remove that the results were by chance, and we came to know that the model was consistently performing well with newer data sets also. And so we were able to say that it's a good generalization. Now, last slide is when with our feature weighted linguistic classifier, the accuracy was 90%. But when we using our training data, we try to use the other machine learning classifiers like neo bias to decision tree. And this is what we found, the result, that on the right-hand side, we have prediction accuracy. On the left-hand side table is the true positive rate. Prediction accuracy of our FWLC classifiers, the 3 variants, ranged from 83 to 90%, but the true positive rate was ranging from 75% to 91%. But for the machine learning classifier from neo bias to decision tree and SVM, we saw that the accuracy was slightly higher, but the true positive rate was very low. So it was very poor on predicting the positive plus, that's the novel words. That was the objective, to predict the novel words from the slide. So the machine learning classifiers were not predicting the novel words. So because the TPR was very low. So that said, we conclude that so these were our observations, that for 10 subjects, the model achieved 23.67% higher prediction accuracy than our baseline classifier, which was majority voting classifier. And with subsequent subsets also, we saw the same accuracy and the true positive rate. So there are many applications in clinical research, right? Eye movement analysis is study for identification of ocular diseases as well as mental and neural disorders such as autism spectrum disorder, ADHD, and Parkinson's diseases. And presently, we are also working upon prediction of dyslexia and dementia as an early predictor. So we're trying to build early predictors for prediction of dementia and dyslexia. My PhD students are working on this using eye tracking and brain-computer interface. So the conclusion is, I know it was short time. I ran through many slides, but if somebody is interested, can always reach out to me. This is the protocol. We had IRB exemption for involving human subjects for the research. And these are some of the research papers which were used, which were the outcome of the study. These were the patent which we filed. And these are the references. And this was the journey while I did my research. This was my family who sacrificed. And thank you. I am hoping some questions. If you want to reach out to me for more information, please do so. I am reachable here on this email address, saurin.parikh@nirmayuni.ac.in. So what we hope to have a product is, while I'm taking the online course, our student is taking online course, we should be able to our model is able to predict that the student thinks he knows the word, but our model will predict whether the word his level of learning, and would provide supplementary learning content related to the content which is not learned from the slide before continuing to the next slide. A simple example is like a word adapt. We know a word adapt. If you change the word, a single vowel in it, we can have three variants of the word. So ADAPT, ADEPT, and ADOPT. For a non-native English reader, we only know one of the word, and the other two words are low familiar words or novel words for us. But we sometimes try to fit in the meaning of another word and think that we understood the meaning of the word, but our model will be able to predict, based upon eye responses, will be able to predict that the level of learning for the word, whether the student perceived the word as novel or has not familiar or has learned the word from the context. So presently our model does the multi-class classification, classifies every word or term into novel, low familiar, high familiar, or not or learned. So I come to the end with that. Thank you for the patient listening.
Participant, any question? Anyone has any question or query regarding the research that proposed by Dr. Parikh?
So our model will be able to highlight, while you are reading in Kindle any book also, it will be able to highlight the level of learning, and for whatever you're not understood, it will highlight and will provide you automatically supplementary learning content which can help you learn the meaning of that. So right now we are talking about at a word level, but it can be expanded to sentences and the paragraph also.
Okay, Dr. Parikh, thank you very much for sparing your valuable time for this your talk. Thank you very much, sir.
Thank you, sir. Thank you for the invite.
Thank you. So next we have this technical session as 6. I would like to invite Dr. Tanuja Dope. She is working at Bharati Vidyapeeth University, Pune, India. Her areas of research are mainly machine learning and deep learning. So I welcome you, Dr. Dope.
Thank you very much, sir. Thanks a lot, Dr. Kanu Patel, sir, for giving me opportunity to serve as session chair for your conference. Thanks a lot. And I welcome all the presenters who are there in this session.
So in this session, we have 4 papers. Out of these 4 papers, 2 papers are like author of 2 papers are going to present their paper online, while Authors of two papers have submitted the pre-recorded video of their speech. So first paper is 281. Dr. Polas, are you there? I think I made you the presenter. So would you like to present your paper online? Mohammad Islam Polas?
Yes, sir. Can you hear me?
Yes, we can hear you. You can share
Sir,
your.
uh, I did submit the pre-recorded video, sir. Should I play or you are going to play, sir?
Okay, if you want to present your paper online, then it's okay. Otherwise, I will play your pre-recorded video.
Sir, please go for the pre-recorded video, sir.
Okay.
Hello everyone. Hello everyone. I'm Mohammad Islam Polash from Bangladesh. I'm happy to participate in the fourth International Conference on Soft Computing and its Engineering Applications. Thank you to the organizers for arranging an excellent conference. My paper title is 5-Year Life Expectancy Prediction of Prostate Cancer Patients Using Machine Learning Algorithms. Men after the age of 40 start to face prostate problems like frequent urination, needing to get up at night to urinate, pain during urination, prostate enlargement, etc. After a particular time, there is a possibility that it will become a cancer. 60% of prostate cancer patients' age is above 65. So after age 40, men should take extra care of their prostate. Last year, 1,414,259 new cases were diagnosed with prostate cancer. Day by day, it is becoming a global issue. For that, we have created a prediction models to tell whether prostate cancer patients will have a 5-year lifespan or not. Our main objective is to understand if a prostate cancer patient will survive 5 years or not. A doctor may see nearly thousands of patients with prostate cancer in his entire life. Based on that, doctor try to understand the severity of patients, make treatment plan. But here, our prediction model has been created with more than 50,000 records and machine learning algorithms. So it will be more accurate than the doctor's self-prediction. It will help doctors to understand patient severity and can make an optimized treatment plan. Here are some words, those are related to our task. Paper 234 have done same kind of research for breast cancer patients. Paper 1 done for prostate cancer, but their data is old, from 2004 to 2009. On that time, 15 attributes were available in the database. Now we use 27 attributes and their accurateness was 85.64%, but we achieved more than them. That will be discussed in our results section. Here you can see the diagram of our research methodology. First, we have collected data from CR database, that is Surveillance Epidemiology and End Result Program. They collect cancer-related data all over the world. After collecting data, we have prepared the data for feeding the machine. All the preprocessed tasks have been done here. Then we have done the correlation analysis and filtered the same behavior attributes. Then we splitted data for training and testing. Three ratio we followed here for train and test: 80-20, 70-25, and 70-30. Then we have built the prediction models using machine learning algorithms. After impact cancers. We also drop the missing records because as cancer is a secret disease, feeling missing data can take us to wrong direction. We also drop the duplicate data that can probably show a misleading accuracy. So we drop those. Then we have done the correlation analysis and taken unique features. Finally, 57 attributes and 54,731 records taken among 187,798 data for modern living. Here we can see the zoomed correlation heat map, and the table on the right side contains the highly correlated attributes whose coefficients are more than 0.9. So we have taken only one from these pairs. We have used nearly 30 machine learning algorithms to build the prediction models. Here on the left side, top perform models are mentioned, like gradient boosting, light gradient boosting, Ada boost, random forest, extra trees, distant trees, and the artificial neural network. After building model, we try to increase the result by tuning the models. On the right side, you can see that with the help of scikit-learn and randomized CV, we have tuned the parameters and applied improved gradient boosting algorithm, light gradient boosting algorithm, and the random forest algorithm. Down here, you can find the result of the prediction models. Our top most performer is gradient boosting model. On the left side, we can see gradient boosting has 0.904 AUC score, mostly covering the data. But the light gradient boosting and the Ada boost doesn't have much difference. On the right side, we also find that the gradient boosting has higher sensitivity and specificity compared to other models. Already we said that we have tuned the models. After tuning our top performer gradient boosting model, we found that the accuracy increased 88.386% to 88.85%. If we see other matrices like F1 score, precision recall, cross validation, we can see little increase in every measurements. The changes of the confusion matrix is also visible. And finally, the training error and testing error doesn't have much difference. That's why we can say that the models are not overfitted. Here you can see the overall results of our models. Top 3 model performance are so close to peak the proposed model. For that, we have analyzed the prediction time of models, how much they take in different platforms. We use 3 different CPU using single thread based the time. Different split of data has used to view the time. Here you can see the time for test data. The TO2 gradient boosting take average 14 seconds to predict the test data, while Ada boost and light gradient boost taking 2 times more for the prediction. So we can decide here tuned gradient boosting will be our proposing model. In conclusion, we can say that we are providing a gradient boosting prediction model that is optimized. Results are higher compared to previous work. Our processing techniques, models, prediction time, calculation, and model tuning make the results different. Now, doctor will be able to understand patient's 5-year lifespan and sense the severity, and also can take proper action for the patients. In future, there is a possibility to make this kind of lifespan sensing model for all cancer in a one single model that will be help doctors for all kind of cancer patients lifespan and severity understanding. That's all for me. Thank you for your patience.
Participant, if you have any question, you may ask.
Hello, sir.
Yes.
I am having one doubt in the result section, sir.
Okay, ma'am.
Can you please show that last PPT?
Here I have this like just a minute. Let me try.
Hello everyone. and view the data. Here you see the
Yes.
timeline for test data. The TO,
Yes.
This one?
Yes, sir. Because my question is that how the author has predicted 5 years life expectancy, because these results are okay. So authors are here or no, sir?
Yes, yeah, I got your question, ma'am.
Yes.
Actually, in our dataset, there was an attribute that is
Hmm.
survival time. Okay, that survival time carries generally 1 month, 2 months, 3 months, like this way. So on from that attribute, we have generated another attribute which patients are lived uh, under 60 months or 5 years, under 60 months, and we have another class that is above 60 months. So we made that an a binary classification problem, and then we dropped the survival months attribute. Then we have applied the machine learning algorithms and tested the performance and different measurements. In this way, we try to predict the 5-year life expectancy.
Okay. Okay. Thanks a lot.
Thank you.
Any other question from audience if you have? Okay, then Dr. Dobe, shall we move to the next paper?
Yes, sir. Please.
So next paper is 112. I think author is present here.
Hello.
Yes, Dr. Singh.
Yes.
Just a
Yes. Morning, sir.
moment. Now you are the presenter, so you can share your screen.
Sure. Yeah, sir, my screen is visible.
Yes,
Okay. Shall I start?
yes, you can start.
Okay. So, good afternoon, everyone.
Start your
Myself,
presentation.
Dr.
Switch to the
Yeah.
presentation mode.
Okay. Okay. Is it visible now, sir? Yeah, so good
Yes.
afternoon, everyone. Myself, Dr. Rashmi Sani, and the title of my paper is Brain Tumor Classification Using VGG16 MobileNet Deep Learning Technique on Magnetic Resonance Imagery, that is commonly known as the MRI imagery. So these are the other co-author, Prabhakar Sembal and Tushar, Dr. Tushar. So the content we are going to present, the objective of the work, introduction, a little bit of the literature review, then data set, and thereafter data processing and data preparation, methodology, and the classifier used, followed by the result discussion and references. So the objective of the work, we say the research aim to look at the significance of MRI technique to quickly detect the tumor and its classification. So we can understand in the today's scenario, globally, the brain tumor is one disease that is affecting human life globally. And it is like a severe condition that may threat to the human life. So in this work, we are going to detect the brain tumor by using the deep learning technique. So the study uses VGG16 and MobileNet V2 deep learning model by using the MRI imagery to develop a comparative result efficiency for the better result. Usually, the manual classification for different type of tumor is a challenging task as well as depend on the expertise of the available human resources. So we can understand that in the present scenario and for the developing countries like India, where For everything we are depend on the expertise in the domain, that is the doctors. And if we develop some kind of the system that will assist the doctor in some way, that may be quite helpful. So a little
Yes, sorry for interrupt you.
in that particular direction. Yeah,
Are you on
yes, sir.
the slide?
Yes, yes, sir. My slide is visible to you.
We can see the first slide. I don't know what about
Okay,
the
sir.
other two.
Actually, uh,
Yes, it's an
sir,
object.
can we yeah,
Yes,
can we use this particular mode, because I think slide switch is not
no problem. No
uh
problem. Okay, fine.
okay, thank you. So as we are talking about the deep learning model for the brain tumor detection, so the recent advancement in the learning based technique, either we talk about the machine learning or the deep learning, have shown the promising result for the brain tumor classification and as well as the detection. And the problem motivation is a, like we can say, the brain tumor is an abnormal growth of cell that in the brain tissue, and the earlier detection or for the identification of the problem may be quite helpful to save the human life in order, because the doctors can plan the treatment plan in a better way as compared to the later on stages. So it is useful for the decision making strategies for doctors for the quick identification of the tumor as well as for the treatment. So the magnetic resonance imagery provide the detailed information about the brain, where we use that is for the information like the sizes, the location as well as for the shape. And if we talk about the little bit about the previous studies or literature review, then Mehrotra performed a study to classify the brain tumor into the different categories, and by using the MRI dataset. And this study used the AlexNet model, that is also a deep learning model. And and another study performed by the CNN algorithm, that they have used the bread data set, and the accuracy they have concluded the 93.1%. Whereas we can also use the another features like the GLCM, that is the gray level covariance matrices, that is useful to provide the additional information as compared to the base data or the input data. So some authors also use the GLCM model, whereas the other people have used the deep learning as well as the machine learning model. So the another study performed by the Swati and all, and they have performed the brain tumor classification using the MRI images, and the study demonstrated that the overall accuracy reported by the 94 point something. So this is a workflow for our study that we have downloaded the magnetic resonance imagery MRI dataset. So we can understand that here we have the four category of the tumor. First one is the normal imagery, and then we have the three different categories for the tumor. And we partition the dataset into the training and validation as well as the testing. And the training, we have used two different deep learning model, that is the VGJ16 and the MobileNet. And here we have used these two deep learning model, trained these model by using the 70% of the input data, and thereafter we have performed the assessment of accuracy on the trained model, and the final accuracy measures has been used, for example the precision recall and F1 measure, and the classification has been performed as an outcome as shown in the slide. So this is our data set that is representing the data set we have used from the Kaggle platform, and the total imagery that we have used for the MRI, that is the 8,334. And these imageries are categorized into the four different categories, that is the glioma, malignant, pituitary, and the normal imagery, whereas the training and testing and validation corresponding imagery are also shown on the table. So these are the data set that we have used for the different imagery. So glioma, the first one, and the meningioma is the second MRI imagery. Then we are having the normal MRI imagery, and pituitary was the third way of classification. So these are the overall we are having the 4 different categories. So the result of the study, we have used the 2 different deep learning model. The first one is the VGG and the MobileNet V2. So that the MRI imagery are classified into the 4 different categories. And here, one thing I would like to mention, that we have trained both the model up to the 50 epoch in order to obtain the better result. So these are the parameters detail that we have used for both the kind of the deep learning model. The first one is the VGG16. These are the information about these parameter, and the second the information is provided for the VGG16. As I have already told that we have used maximum number of epoch is the 50. This is the summary of the overall classification performance. We have used the first one is the tumor type, then we are having the true value and the predicted value, and it is providing the we can say the confusion matrix regarding the obtained result. And later on, the second table representing the tumor types as well as the different evaluation parameter that we have used in a generalized manner. We have evaluated the accuracy for the F1 score, that is the harmonic mean of the precision and recall, because in general we have find out that the F1 score is a quite good measure when we talk about the class specific accuracies. So these are the result, and this is the result that is obtained by the VGG16 model. In the similar manner, the first table represent the confusion matrix, where the diagonal value is representing the true value or correctly classified value, where, and the other values are representing as a wrongly classified value. And the second table is representing the tumor type again for 4 different categories, and there the parameters we have considered for that. And we can say that the if we compare that for the known tumor category, we have obtained the highest F1 score in the similar manner that the highest F1 score is also reported by the MobileNet V2, that is the and similar manner the another classifier VGG16 also reported the highest F1 score for the non-tumor class. These are the model progress. That is the training graph we have obtained when we trained our model up to the 50 epochs. So first one graph is representing the train accuracy and the validation accuracy, whereas the second one graph is representing the loss graph with respect to the number of epochs. And in the similar manner, this is the accuracy epoch plot for the VGG16 model, and the loss plot is for the VGG16 model. So these are the result. So the major objective of the study is the multi-class brain classification by using VGG16 and MobileNet V2 technique. The result demonstrated that the both deep learning models successfully detected the brain tumor and classified these into the different type of category. And it is found out that the MobileNet V2 obtained the highest overall accuracy of, that is the 97.46 percent, which is significantly higher as compared to the VGG16 model, that is the 91.46%. So the finding of the study indicate that MobileNet V2 deep learning model is more stable in terms of the training and the validation accuracy, as well as the loss and with respect to the number of epoch. It is also observed that the MobileNet V2 training time is significantly lower as compared to the VGG16. And therefore, we can conclude that the performance of the deep learning model is significantly affected by the tuning parameter and the size and the selection of the deep learning model, that play a very important role in order to obtain the accurate result. So these are the references. And Thank you. This is all from my side.
Yes, Dr. Durbe, any
Yes,
question?
sir. Yes, sir. Very nice presentation, Dr. Rashmi. But I am having one doubt that when
Thank you,
we
ma'am.
talk about the accuracy of a particular model, now in the graph, that is, can you
Okay,
please
ma'am.
scroll up um, slide number 14?
1 minute, ma'am. Yes. Yes, ma'am.
Slide number 14, please.
Yes.
Now here you have shown the training accuracy and validation accuracy, and then in the second one you have
Yes,
shown
yes.
train loss and validation loss. My question is that
Yes.
why you have not shown in the graph about the testing accuracy?
Pardon?
Because when we talk about why you are not talking about the testing accuracy, because the thing is that when we talk about the
Hello.
hello.
Ma'am, actually, I'm not getting your question because your voice break. I'm not getting your question. Please repeat.
Okay. Now in these two figures, you have shown the
Yeah.
train accuracy, validation
Yes.
accuracy, and in the second
Yes.
graph, you have shown train loss and the validation loss.
Yeah. Yeah.
But as far as my knowledge is concerned, that when we take the data set for the training, part of that data set we reserve it for the validation purpose. And then when we talk about the testing data, okay,
Yes.
based on that we always talk about the accuracy. So have you plotted the graph based on the test accuracy as well?
Ma'am, actually, we have also plotted the graph based on the test accuracy. But usually, what happened?
Okay.
The page limit here, page limit was, I think, maximum pages was 13, and my content, whole content covered the 13 pages. That's why we excluded these graph. This is the reason. Hello,
I think you can
hello.
here in this graph, no? Testing loss and testing accuracy.
Okay, okay, sir. Yeah,
Okay,
yeah,
Dr.
yeah, sir.
Just tell me.
Any other question from the audience? I think no question from the audience. So shall we move to the next paper, Dr.
Yes,
Dubey?
sir. Yes, yes.
Author is saying the Rasmi Saini.
Mhm.
Paper ID is 111. Yes, Dr.
Sir, my screen is visible to you.
That
I switch. Okay,
the
I
screen is
changed it.
visible, but it's a paper 112. Still, you are on a 15 slide.
I'm switching the screen. Yeah. Yeah, is it okay now?
It takes some time. So yes, we can see your screen.
Okay, okay,
You
thank you,
may
sir.
continue.
So, I'm having the second paper for the conference, and the paper title is the automatic mapping of deciduous forest and evergreen forest by using machine learning and satellite imagery. The co-author for this work are Suraj Singh and the Dr. S.K. Verma, belongs to the GP Pant Engineering College. So the title of the paper is the automatic mapping of deciduous forest and evergreen forest using machine learning technique and satellite imagery. Here, the content of the talk will be introduction, a little literature review, a study area, the data set used, followed by the methodology, discussion, conclusion, and final outcome in terms of the classified map as well as references. So, the forest play the significant role for the human life and its affect the complete ecosystem. So, we can understand the forest is one precious natural resources that completely affect the ecosystem as well as the temperature for the environment. So, the forests are important for the ecological balance, climate change, biodiversity, water conservation, carbon balance, economic development for any country. So the information in the forest is very important regarding the forest is like we can see the crucial parameter for the different scheme for in order to obtain the like how much forest cover we are having. So the automatic forest mapping through the processing of satellite imagery provide a quick and the precise information. Here I would like to mention one more point. If we go by the manual detection technique, right? If we visit the field and then find out the information about the any object or any information about it by using the manual method, then we can understand it is the tedious job when we visit the field and get the information. Whereas in terms of the satellite imagery, when we are having the satellite imagery, we are having some good technique. We can say either the machine learning or the deep learning. Then by combining these two, sitting here at my office, I'm getting the information about the forest cover. And this is like we can understand the importance of the satellite imaging or the remote sensing domain. So a little bit of the literature review. The previous study performed by the NOI utilized the Sentinel-2 image data, that is for the land use land cover classification, and comparison is performed by using the K nearest neighbor, support vector machine, and RF. And they have highlighted and find out that the FEM has obtained the highest accuracy as compared to the other classifier. Whereas the model compared the Landsat and the Sentinel-2 data for the South Asian forest degradation using random forest classifier, and the study demonstrated that the vegetation state in the most countries are like fluctuated over the time and with the localizing greening and using the sustainable development. And the another study performed by the Hoshialio that in 2019 the multi-temporal Sentinel-2 data by combining the topographic information for mapping of the forest and non-cover forest by using the RF model, and study demonstrated the multi-temporal Sentinel-2 potential in order to classify the data. So here in our study, we have considered the district Dehradun situated in the Uttarakhand, India. And this is located in the northern region, and most of the area is here mountainous. The area of the located here is the Shivalik and some area in the like the foothills of Himalaya, we can say. And the total area covered here in our study is 3088 kilometers square by having these the as mentioned the latitude and longitude information. So this is the location of our study. We can understand that we have represented to make our understand in a better way. We have demonstrated the country India. Thereafter, we have highlighted the Uttarakhand state by the brown color, and the green color is representing here the our selected study area. And at the rightmost side, we have represented the selected study area in the true color composite. We can also go for the false color composite, but this is the true color composite. As we can see from the figure that most of the area is mountainous in the selected region. So the data set we have used is the Sentinel-2 satellite data for the winter session, and we have acquired this information for the December 10, 2021. That is the recent data we have taken. The data collected from Sentinel-2 and the resolution we have considered the 10-meter resolution for the classification purpose. The bands that are here, that is in here, that is green and blue, are the bands that we have considered the NIR. And why we have chosen this data? The reason is that it is having the medium spatial resolution data that is quite suitable for our application, as well as it is freely available. Whereas if someone wish to go for the higher resolution data, that is like not freely available, and that is quite expensive. So we have chosen the freely available data. So these are the four band which is highlighted we have used for our study: the blue, green, red, and the near infrared, and their corresponding spatial information, central wavelength, and the bandwidth have been represented. So this is the workflow for our study. We are having first what we have done, we have the image acquired for the data Sentinel-2, the single date image we have acquired. Then we have performed the atmospheric and radiometric correction, that we call it the pre-processing. Thereafter followed by the band stacking and the individual tile in order to form the final imagery that is used as an input. Then mosaicing of the tile is performed. Mosaicing, basically why we performed it. The reason is because my study area is not covered by a single tile. That's why I have to perform the mosaicing as well as the clipping in order to obtain the desired study area. And here, for the reference data, we have taken the Bhuvan ISRO map for the reference, as well as the Google Earth imagery we have taken as a reference. We have partitioned it in the training sample and the test sample, and we have taken 70% of the test training sample and 30% as the test sample. The classifier we have used here, the machine learning classifier. The first one we have taken the random forest classifier, and second one is the KNN classifier. Then we have performed the train the classifier, perform the classification. Then we have prediction and assessment by using some accuracy measure and the result. So these are the steps that I have already explained: the atmospheric correction, stacking, band mosaicing, shapefile, clipping, data visualization. These are the steps. So the classifier we have used, the well-known classifier, so we are not going in detail that of these classifier. The first one is the random forest, and second one is the k-nearest neighbor. So the result we have obtained for these two classifier are random forest. We have obtained the overall accuracy of 81.52%, whereas for the KNN classifier we have obtained 80.84% of overall accuracy, and the kappa value is corresponding 0.759 and the 0.75 for the KNN classifier. And the class specific accuracy here, we can see the first column representing the class name or the land use land cover category. So we are having the water bodies, the river, the deciduous forest, the evergreen forest. These are to our target classes. And shrubland, vegetation, fallow land, and urban or the semi-urban area. So this is the F1 score that is obtained by the RF classifier, and second one is the F1 score obtained by the KNN classifier. So the discussion, the RF achieved the overall accuracy of 81% with a kappa coefficient of 0.759, whereas the KNN obtained the overall accuracy of 80.84%. And both the classifier performed well, but we can see that random forest achieved slightly better result as compared to the KNN. It is found that the user accuracy produced by the RF is for the deciduous forest and evergreen forest is 77.53% and 82.26%, whereas the producer accuracy for forest is 82.85% and 77.95% respectively. It can be observed from the result that the sum of the misclassification of the sample from the deciduous forest and the evergreen forest is occurred in the classification result. And some of the sample of both the forest type are also classified as other vegetation categories such as the shrubland and cropland. Why it is so? Because it is very difficult in order to classify or the map or to map a particular class with a very high accuracy, because we are having the similar spectral characteristics. So it's very difficult to identify or to classify some kind of the classes which is having the similar spectral category. For example, like we can say the water body can never be going to mix with the forest because they are having the different spectral signature, whereas the one forest type will be misclassified as the another forest type because of the spectral similarity. So in other words, we can say these are the challenges that we are going to face. So this is the conclusion, and this is the final outcome that is obtained by our KNN classifier. study, that is, this is the classification map that is represented by the random forest classifier using the 4-band dataset. So we can see the upper half of the study area is dominated by the evergreen forest, whereas the lower part of the study is represented or the dominated by the deciduous forest. And this is the classification map by the KNN classifier in the similar manner. So these are our final result. So these are the references, and thank you. And if anybody have question, please. Hello.
Good morning.
No questions.
Okay,
Good morning.
Dr. Yes, anyone has any question?
Good morning.
Good morning.
Good morning, sir. I have a question.
Yes, you may ask.
Please, what type of uh, analysis software you need you to carry out the analysis?
I'm not getting your question. Please repeat.
Is it Python? Is it Python you use? Or other
Okay.
programming?
You wish to ask
Whichever
which
analysis
platform
software
I have used, right? Right?
Yeah.
Okay. I
Yes.
have performed all the classification in the R programming language.
Art programming.
Yes.
Hello? Hello, sir?
Yeah,
Yes.
yes, R programming language.
Thank you. Hello? Hello?
Thank you.
Any other question? Okay, Dr. Dupe, you may continue.
No, sir. I don't have any questions. We can move to the next presentation. Thanks.
Next paper is 156. Author has submitted.
So thank you so very much.
Thank you. Isma Damalia, are you there?
Yes, sir, I'm here.
Just a minute. Would you like to present your presentation live?
Sir, my network is not very stable. That's why I submitted the pre-recorded presentation.
Okay. Let me play your presentation.
Yes, sir.
Okay. My network is not very stable.
Greetings to everyone present here. Greetings to everyone present here. Thank you for giving us the opportunity to present our work today.
Sir, I don't believe it's audible.
Just a minute.
Yeah.
One. Just a minute. Actually, I'm not getting audio. One minute. not getting audio here. Video. Could you present online?
Okay, sir. But in case I have any issues with audio or something, just let me know.
Yes, sure. You can share your screen.
Yes, sir, sharing. Is it visible, sir?
Yes.
Okay, so greetings to everyone present here. My name is Karishma Damania, and I'll be presenting our paper titled Graph Convolutional Neural Networks for Nuclear Segmentation from Breast Histopathology Images that Dr. Angel Jyoti and I have worked on during our time at Birla Institute of Technology and Science, Pilani, Dubai campus.
Just try to complete in 10 minutes.
Yeah.
Sorry for interrupting.
No problem. So as we know, the analysis of H&E stained images obtained from breast tissue biopsies is one of the most dependable ways to obtain an accurate diagnosis for breast cancer. In recent times, several deep learning techniques have been explored to develop a computer-aided diagnostic system to perform nuclear segmentation of these images to obtain the segments that indicate the presence of a malignancy. Traditional CNNs have seen remarkable success when it comes to this task. However, there has also been recent success suggested by several studies that made use of graph convolutional neural networks with computer vision tasks such as segmentation. And thus, through this work, we aim to design an architecture called Graph Segnet, which is a GCNN that follows the encoder-decoder architecture of the well-known network Segnet to perform nuclear segmentation. So the dataset used for this study is taken from the UCSP biosegmentation benchmark, which consisted of 58 H&E stained images obtained from breast tissue biopsies. The H&E stain is a commonly used dye which binds particularly to some components of the cell, highlighting them and thus making it easier to identify cell structures. The dataset consists of stained histopathology images of sizes 896 into 768 pixels, and their corresponding masks indicate the cell nuclear segments that are then used to identify whether the cells are benign or malignant. Some sample images and their masks from this dataset are shown in the figure. A short literature review. So some of the works conducted on the dataset used by us or the UCSP dataset included a study that was a pixel-based method that used a superpixel algorithm to perform segmentation for the histopathology images and was able to achieve an overall accuracy of 69.64%. Another study also performed color decomposition with machine learning classifier SVM or support vector machine to obtain an accuracy of 80.2%. And another methodology adopted made use of semi-supervised optimization model to perform the segmentation, and the results obtained presented an accuracy and F1 score of 89.55 and 77.33% respectively. And further, another CNN model proposed was able to achieve an accuracy and F1 score of 90.15 and 90.44 on the UCSB dataset. And this one included generating a very large number of patches due to the lack of available data. These and several other studies have worked and experimented on the same dataset as us to perform nuclear segmentation. And in order to do the same, we came up with the following methodology. So the following structure was used. As part of the data processing phase of the methodology, we performed data augmentation and image normalization. And the images were then converted into adjacency matrices that represented the features of the images, and these were then fed into the graph segment architecture. We then use the necessary evaluation metrics to assess model performance. One of the prominent challenges of working with histopathology image segmentation is the lack of data. For training a graph neural network, the more the number of available training images, the better the subsequent performance of the model. Thus, in order to create more training samples from the pre-existing images, data augmentation was required. While dealing with segmentation, of course, any augmentation performed in the image needs to be simultaneously performed in the masks as well. So in this paper, we performed horizontal and vertical flipping as well as random rotation in order to increase the number of images available. And the augmentations applied to a sample image and its mask is available as shown in the figure. Another lingering challenge when analyzing H&E stained images using deep learning techniques is the variation of color and intensity due to the nature and extent of the stain. So our images were resized to 256 into 256 pixels and transformed from RGB to grayscale matrix using the threshold and distance transforms in order to convert them into adjacency matrices for feeding them into the model. Further, it is essential to perform image normalizations in order to rescale the pixel intensities of the images from a range of 0 to 255 to fall into a scale between 0 to 1. And this was achieved using the min-max normalization, the formula for which is on the slide, where X max and X min refer to the maximum and minimum pixel intensity values of the images respectively. Sorry. GCNNs are an optimizable transformations on the attributes of a graph, essentially, which are the nodes, edges, and the global context. And the network is able to use the features represented by the graph, learn the associations between them, and produce the outputs as required. Most commonly for feature representation between data, an adjacency matrix is used. Convolutions and operations in GCNNs are performed on these adjacency matrices for image such that each pixel becomes a node, and the kernel sizes determine the number of nodes processed in one convolution. In order to transform the images into an adjacency matrix, their pixel values are projected onto a 2D lattice, and the consequent features were used to obtain the graph. Once feature representation through the adjacency matrices were obtained, the problem was then reduced to a graph classification task. Here is our model. So GraphSegnet makes use of semi-supervised learning in its graph convolutions, followed by graph pooling and unpooling to perform the upsampling and downsampling of the images. The proposed GraphSegnet consists of 5 stages of encoding and 5 stages of decoding as depicted in the figure. Stages 1 and 2 have 2 layers of graph convolutions, each with node embedding size of 64 and 128 respectively. Stage 3 has 3 layers of graph convolutions with node embedding of size of 256, and stages 4 and 5 have 3 convolution layers, each with a node of embedding size of 512. After the convolutions, graph max pooling is applied to reduce the size of the feature set by returning the batch-wise graph level outputs by taking the channel-wise maximum through the node dimensions. These pooling indices are saved in order to recall and pass them through to the decoder stages. By accurately recalling the previous location of the nodes before pooling, the model is able to recreate the graph, placing the nodes from the positions acquired from the corresponding pooling layers. For the decoding part of the network, the pooling indices passed on from the respective encoding stages is then used for upsampling. Stages 6 and 7 consist of 3 graph convolutional layers with node embeddings of 512, followed by stage 8, which has 3 convolutional layers of node embedding size 256, and lastly, stages 9 and 10 consist of 2 graph convolutional layers with node embedding size of 64. Each of the graph convolutional layers are followed by batch normalization and a rectified linear unit. So speaking about the implementation details, to obtain the training and testing images of the data was segregated into an 80-20 split, and the PyTorch model was used in order to load, concatenate, normalize, and augment the images as part of the data cleaning and pre-processing. The GC and convolutional layers and graph pool and unpool layers offered by the torch geometric module was used to build the convolutional blocks of the network and for the downsampling and upsampling process respectively. The batch size was set to 32 and the model was changed for 100 epochs. And further, a callback function was used in order to monitor the validation loss in order to reduce unnecessary training and overfitting by interrupting the training if sufficient improvement had not occurred for one was used along with binary cross entropy for the loss function. The following evaluation metrics were used and their calculations are on the screen. And the evaluation metrics are intersection over union, the dice coefficient, pixel-wise accuracy, precision, and recall. After training the model as per the implementation details explained above, the segmentation results of the models are obtained as depicted in the table, achieving an IOU score of 77.5%, pixel-wise accuracy of 79.46%, dice coefficient of 78.55%, precision of 71.4%, and a recall of 87.3%. The first figure on the slide shows the training and validation accuracy and dice coefficient values, and the second figure shows the original mask and predicted mask, through which it is evident that the semantic segmentation was performed well, and the output mask predicted by the model is quite close to the ground truth mask, hence providing a visual confirmation of the success of the approach. Upon comparing the results obtained through the study with other methodologies carried out for the nuclear segmentation using the UCSB dataset, we can see that GraphSegnet is able to approach similar results for far less image processing and training. Since the efficiency of CNNs is largely dependent on the number of training samples provided, this explains the significant difference in some of the performance metrics. However, since GraphSegnet was able to perform comparably well with this methodology, it can be inferred that using GCNNs for the purpose of nuclear segmentation of breast histopathology images is one that holds immense potential. The success of this architecture is rooted in the fact that, similar to SegNet, the underlying principle is that while performing pooling during the encoding and downsampling stage, the pooling indices are retained. Since pooling helps to reduce the feature map sizes by retaining the more representative features, storing their pooling indices and passing them on to the decoding layer helps the network to efficiently place and localize the most significant pixels after unpooling and upsampling. Thus, through this study, it can be concluded that the architecture proposed along with this methodology performed well for the purpose of cell nuclear segmentation. And the future scope of the study can be further expanded by experimenting with more graph transformation operations to create more accurate and representative graphs, to perform more data augmentation to increase the sample size and increase the number of patches, and consequently graphs generated, or to experiment with more architectures, or simultaneously even performing classifications of the obtained segments to fully automate the process of detection of malignancies, thus maximizing the capabilities of using a GCNN for this purpose. That brings me to the end of my presentation, and here are the references just in this PPT. Thank you so much.
Dr. Dope?
Nice presentation. I don't have any questions regarding this.
Okay, thank you.
Any participant have any question? I think no question from the participant. Thank you very much.
Okay, thank you so much, sir. Sir, can you, would it be possible for you to take a screenshot of me presenting?
Yes, we'll provide you. And you also get from this Microsoft team. You can download the video.
Okay, sir. I will just go back to.
Okay, Dr. Dope, thank you very much for sparing your valuable time for this chairing the session.
Thanks, sir. Thanks for giving me opportunity to serve as section chair. Thanks a lot, sir. Bye.
We will meet again. Participant will meet again at 1:30. Currently, we have lunch break.
National level student technical paper and project competition.
मॅडम म्हणजे मला सर